Reason we're here for today, Cellular Diffusions webinar. We're so excited for this one, which is going to be using concepts of voxels and cellular automata along with AI to make these really cool structures and images. Little introduction is we have Stepan, who is an award-winning architect, computational designer, co-founder, and CTO of Kodiia, partner at SA Lab, and tutor at Digital Futures, ECAD, and more. And we have Alec, who's a senior architect at Cloud Cooperative in Vienna, Austria, computational designer, university lecturer, BIM specialist, Autodesk expert, elite alumni. So welcome you both, and I'll stop sharing now. And right before we start, just want to mention to everyone here that this is recorded. And the recording will be emailed to you. The recording link will be emailed to you after the webinar once Zoom processes it. Since this is a recording, and we want to give you as much information as we can in five or so hours. If you feel you can't keep up with the pace, or something's too fast for you, or something's not working properly, don't worry, because it's recorded, so you can always go back and watch the recording as well. And if you have any questions during, please ask them in the chat or with the Q&A button. So without further ado, I'll hand it off to you guys to kick off this webinar.
Okay, cool, thanks. Well, first of all, hello everyone, and thank you guys from Design Morphine for having us here, for inviting us, and making this webinar a reality. I'm really looking forward to it, and I'm gonna start with a short intro. Like 30 minutes before, I was sure I will be starting with a brief presentation with some images, PDFs, and so on. But now I don't feel like this. And I think I'll just start with some screen sharing and tell a little bit about me, about what we are going to do today. And then I'll switch roles with Alec, and then I'll be back again with teaching part. So
I just want to remind you and Alec, just to switch your chat to everyone if you haven't, in case you guys end up wanting to share anything in the chats. So
okay.
Yeah, and also for everyone else that's in webinar, switch your chat to everyone if you want to chat, with everyone. Okay.
Okay, so hopefully you can see my screen now.
Yep, all good.
All right, so usually nowadays, I tell about myself like I'm an architect turning full stack developer. I started as an architect, designing various projects, and nowadays I'm more into software development. So my part of the webinar today will be more about web design and building your own tools, working with basics of web design languages like HTML, CSS, more into JavaScript, and some libraries like 3JS as well. I'm co-founder at SA Lab, which is short for Smart Architecture Laboratory. We work on various projects from interior design, like this one, for example, where we design complex 3D forms, some kind of installations. This one was made from aluminum, and we did the whole interior as well. And we, at the same time, work on completely digital projects like this one. This is a pavilion for Metaverse Biennale, the first architecture Biennale in Metaverse, which happened last year, if I'm not mistaken. So yeah, we have like very different projects in our portfolio, and My role in this project is mostly technical. I'm the guy writing the code, assembling Grasshopper nodes, making all this spaghetti stuff on your screen, and so on. So I prefer doing some technical webinars and mostly telling some technical things. If you have any questions while we try to dive into some complex technical topics, feel free to ask, and do not hesitate, please, as it will be both beneficial for me and for you. So as I've said before, today our webinar is split in two parts. The first one is dedicated to web design, creating your own software using web tools and using complex algorithms like Cellular Automata to design city neighborhoods. We will talk about 15-minute city concept and how we can implement this using the Diffusion Cellular Automata algorithm. And the next part will be hosted by Alec and will be dedicated to using AI tools such as ComfyUI to visualize stuff and work with 3D as well, if I'm not mistaken. Yes, Alec?
Kind of. We will use your 3D geometry as an input.
All right. So that's it from my side. And I guess Alec will continue with a few images.
Okay. Let me share my screen as well. Just a moment. So you should see a presentation, actually. And I would like to tell you about, not to tell you, like make an overview about the AI in general, how we are using it for the several projects. And it's actually started in ComfyUI, where I've worked before, and right now we are collaborate with several projects. And this was 2021, so it's era before Midjourney, before ChatGPT, before DALL-E, but we already used AI stuff. It was the tool which developed by Daniel Bolojan, who's a really famous artist and developer in the AI area. And he made Deep Himmelblau tool, which is generative AI based on ComfyUI project's dataset. And you can find more information about this tool on this webpage. It's actually ComfyUI website, but the special page about the Deep Himmelblau. And through this tool, you can produce images like in Midjourney or Stable Diffusion or any other familiar tool right now. But in 2021, it was pretty interesting because almost nobody used it. And for one of the competition project, it was the theater project in Kazan, Tatarstan, we produced this image. And on top of this image, we did the team who produced the whole project. I actually was part of this team, but I made like a small Grasshopper scripts there. And the team who making the facade, they're producing this image in Deep Himmelblau tool, and then follow this image, they're making this geometry. So this is the actual render from the render geometry, and you can see some similarities in between these two images. Now, this approach, I would say, it's kind of common. A lot of architectural studios producing images from AI and then starting doing the project. But in 2021, it was not so obvious, and I would say we invented this approach for ourselves. So, but not only these two we used for the same project with AI. Also, we used the the plugin for Grasshopper, which calls Scroll. It's a special plugin. It's already, it still exists, and you can download it from Food for Rhino, for example, for free. And this plugin allows you to create or train your own neural network inside of the Grasshopper and then use it somehow. So what the team did for this project, they making the 3D geometry through this tool and train this tool through the previous from the data set, which also was the previous projects of the ComfyUI. ComfyUI produced a lot of theaters, and inside of the theaters, of course, they had a lot of holes, like main hole, black box hole, and different stuff. And for all these holes, you need to produce the shell. And of course, they had this geometry, and they used it like a data set for the crow, and afterwards produced the new shells for this Kamal Theater main hall. And all this stuff you can see on the screen. This is the variants which were done through this tool, and this also all these variants, but in the different scale. And then using this AI 3D geometry generated by Crow, they did the actual 3D geometry on top of it, which is clean NURBS geometry or sub-D geometry. I don't really remember now what exact tool we used, but it was really fine and interesting approach. And afterwards, after the project, I kind of recreate this tool, but for my own tasks. And I can show you this small video. So I took 5 different topologies, 3D topologies, then produce 1,000 intermediate topologies from that initial data set, and this new data set from 1,000 topologies was my material to teach neural network. Then I took the sizes from each topology, and this was the second data set, because you usually need like a pair that data to train something. For example, if you train neural network like Midjourney, you need images and text. The text should describe images. And in this case, for description, instead of the text, I using the sizes like width, height, and length of the geometry. And instead of the images itself, I used the 3D geometry, of course. And here we see after I trained the model, I can use the sizes as an input. And when I input new sizes, the neural network produce for me new geometry. It's working like that. So this is possible to recreate in Grasshopper, and this is pretty interesting approach, I would say. So the idea is you don't need to use neural network only for the images. It's also possible for other stuff. For example, for Beam as well, it's another one project and another one idea where we integrate ChatGPT inside of the Revit model and ask ChatGPT to analyze the data inside of the model. For example, sometimes if you're working with complex projects and you have a lot of rooms in these projects, different users who simultaneously attached to the model, they for example, can name the similar room with different naming. For example, for toilets, it's possible to name toilet like a toilet or WC or something like that. And we ask ChatGPT to analyze this stuff and assign the proper naming for all these rooms. And you can, it's maybe not a good quality to actually see it, but if I pause it, right now, you can see all this stuff are toilets, but with different names, and ChatGPT recognize them and rename them in the proper way. So this is the idea how you can use large language models inside of your projects. And of course, it's just one approach. You can use them for several tasks, even to produce geometry. It's also possible. So let's go further. And after this ComfyUI theater project, I tried to recreate this workflow with my students, and we also produced first images, this time already with Midjourney, because it was a couple of years ago, and Midjourney already was available, so we can use this freely for everyone, and not totally freely, you can pay for that, but anyway, it's at least available through the website, not like a closed tool inside of the studios. And we produce, as an example, I produced this image, and after explaining to students how to recreate such an image in the 3D environment. So first you need to analyze it, because sometimes a neural network produce something not really possible to construct, not even in reality, but also in the 3D software, and you need to analyze where is the surface, where is the curve, etc., etc. And for that, the sketch is a good tool. You can understand this image more precisely, and then recreate it in the 3D software, for example, in Rhino. And in this case, I used Rhino and SubD, and also a couple of plugins like Nuclei in Grasshopper to create more complex geometry in between these main beams. And in the end, it was done like that. So it's pretty similar to initial image. And then we also generate in Midjourney this character and redraw it manually in Blender. Blender allow you to make handmade drawings, and this is the totally handmade, but with this reference, of course. And you need it because you can animate it. This is not possible to animate it, just an image, but if you redraw something in Blender directly, you can animate this character and make the whole scene, which will be more interesting. So also for producing textures, we used Midjourney and then used these textures in Blender to create the whole scene. And this is the final scene, actually, which were done as an example for the students. And then they produce something else I will show you later. So maybe we don't need to see everything. So also character here and some render effects, and you can see the final result like that. It's not a render, it's just a viewport, but after it's possible to produce renders, of course. Blender is a nice tool for that, and you can make something like this. And using this approach, students divided by team also produce their own geometry and their own projects like that. For example, here is also interesting approach because it's a combination of two scenes. The landscape were done directly through Midjourney, so it's producing automatically through depth map, and you just need an image from Midjourney, and then using the special algorithm you can extrude it to this geometry. And this is also geometry from Rhino, this building, and the combination of these two approach give you this interesting result. Another one seen also from students, it's also interesting project, and I can quickly show you some. This is very similar idea which we will make today, but you will see it later, and another one project, so it's also very cool. And all of these projects started from AI images, and then we produced the actual 3D geometry. So this is the one approach how you can use AI as a reference for your project and then they make the project itself. But it's possible to do it vice versa. So you can make the project which could be pretty simple if we speak about geometry. And afterwards, you can make a pretty complex render using the AI on the finish of this project. So you can use this one way or another. So it's two approaches for that, at least two. It's of course more. And using a modern tool like Midjourney, you can create pretty awesome concepts and then create through these concepts the real projects. So these images I produced in Midjourney, and I would say this is a really nice tool. But right now I'm almost totally switched to ComfyUI because ComfyUI gives you more freedom. You can make a lot of stuff through this tool, and I will show you later. But also for Midjourney, I would like to mention one stuff. If you use this tool, and I recommend to use it, of course, because it's interesting, better if you input not just a text prompt, but something from your own side. For example, in this example, I produced a 3D geometry in Grasshopper, like that, then make a simple render in Blender. And in Lightroom or Photoshop, possible to use, you can change the colors, for example, make a black and white image, and use this image as an input for Midjourney and produce, for example, something like that. It's taking the concept of this image, but also using the prompt, you can create a pretty interesting geometry. So if you are using your own inputs for Midjourney, it's also allow you to create more interesting results. But what about ComfyUI? So ComfyUI, this is just the concepts, and afterwards I will show you the workflow which we will use today, and also the workflow which we won't use today. But anyway, it's possible to use on ComfyUI. ComfyUI gives you much more freedom than Midjourney because it's almost custom tool. You even can create your own algorithms inside of ComfyUI, code your own nodes for this interface, and produce almost everything. And it's not only about AI. I will show you later as well. For example, in this concept, I experimented with different materials of the facade for the same building, and you can see the variety which you can assign to the same facade, even fantastic materials, not existing materials like jellyfish material, for example, or ice, or soap foam, or something like that. So it's pretty interesting. Also, you can use it as a render. So this is the render on top of the real geometry, which we did in Cloud Corporation for one of the competition project in Estonia. And afterwards, I also used this project for testing rendering approach, and ComfyUI gives you really nice renders. And this is the same project, but interior. Also, you can combine different approaches for the same image. For example, combine the model which produced the classical architecture, like a New York buildings architecture, and something like a modern architecture in the same image. And you can say the ComfyUI, for example, use this model for the middle part of the image, and another one model for the side parts of the image. And it can combine this stuff, so it's pretty interesting as well. And you can fine-tune your own model, so you can take your own material, like images from previous projects, or your AI generated images, or something you can find in internet, and train your own models, and then use it to produce something new. For example, here I used the model which were done by Kas Esbach. He is the architect on MVRTV, and you can find this LoRa model on the CVTI website. It's called Ahmed, and it's pretty nice LoRa. I combined it with my own LoRa and produced these images, so it's one of the approach. And I don't know exactly which materials he used to train this model, but it's pretty awesome, and you can create the interesting concepts with it. This is my own LoRa. LoRa, this is the model. We will also use some LoRa models today. LoRa, this is the model which you can train, so on your own materials, as I mentioned before. And you need to prepare data set, you need to prepare description of each image. In most cases, sometimes it's not necessary, but in general you need. And then using the special tools, you need to train the LoRa model and then apply this LoRa model to ComfyUI, and the results which ComfyUI produce to you will be focused on your own goals. Let's say, for example, you need to produce something in the constructivism style, like here, and you can train your own LoRa model for that, and then produce something like this building. So it's one of the approach. And ComfyUI also allows you to use several different base models, like Stable Diffusion and Flux, for example. Flux, it's a model which started this summer, and it was really nice, really realistic, and even if you don't need realistic images like this, for example, it's more focused about the graphical style, so it's also possible to recreate some images in Flux, and for example, like that. So it's close to Midjourney, I would say, because Midjourney is also a very artistic model, and Flux, it's similar, but you can use it on your own computer without connection to websites, and to test this model, you even don't need to pay something, so it's you just need a computer for that, and this is pretty cool. So it's some concepts I did in Flux, and I will show you the approaches which we can use in ComfyUI. Some of them we will try today, but in general, what you can do. The first, it's most simple one, is text to image. When you have a text prompt, and then, for example, like that, you just need to describe your result, let's say, describe what you would like to achieve through this model. This is the algorithm for that. It's actually more complex because it's not just a text to image, it's also upscale part here. I will show you later what it means, but we have here in this algorithm some additional parts, I would say. It's not just text to image, but in general, the idea like that. So you describe your image and then you have this image, and depends on which models you will pick for that, you will have different results. Then image to image, it's the idea when you have not just in the text prompt initially, but also image part, which can affect your final result somehow. And here it's pretty similar. So this is the input image and this is the output, but it depends on parameters. You can make this image pretty different, I would say, if you change these parameters and only keep the idea of the initial image, for example, the color scheme or something like that, and the final result will be totally different. But anyway, it's possible to use the image as an input, not just the text. And this is the second approach, which is also pretty nice. Another one idea and another one approach, it's a control net. Control net is additional neural network which you can use with combination, to combine this model like Stable Diffusion, for example. And control net keep a composition of the initial images, and on top of this you can assign something else. For example, in this example, you can see different weather, so it's different even year time, so it's a summer and winter, but the building is the same. And this is the whole idea of ControlNet. You keep something and change something else. And usually you keep the composition and change the materials, or change the environment, or change maybe part of the image. So it depends on your parameters, and it depends on your workflow. This is another example where you can see the different environment for the same pavilion. And this is also the ControlNet, but here is different approach. It's not just changing the environment. Here we change almost everything, but we're still keeping the composition of the image. So it's totally different structure of these two bridges, for example, or these two bridges. But we keep this whole composition and change the idea of the bridge itself. It's also possible through the ControlNet to achieve something like that. And this is the same idea as for the bridges. It's the same composition. We keep it, but change the facades, not just for the materials, but also for some details. And here more changes. So it's also the composition more or less the same composition of the image, but we change the whole structure, and you can use ControlNet for that as well. And this is the combination of all these approaches, actually: ControlNet, image to image, text to image, and this is the workflow which we will use today in the second part of this workshop. And it's not so big, and I will explain each of these nodes which we will use, and in the end we will have this algorithm in your ComfyUI, and you can create something like, for example, these images or something else. Let's see. So this is the example of the voxel city. And this is the other examples. But beyond this, we will not go to this stuff today, but I just would like to describe for you what you can also create in ComfyUI. For example, you can use it as an advanced Photoshop or advanced image editor, let's say. And this is the example where we have an image and try to delete the background. And this is how ComfyUI did it. And this is, for example, how Photoshop did it. You can see here it's not the best work, actually, but ComfyUI did it pretty well. And this is not stable diffusion or flux or something like that. So you can use ComfyUI for different stuff, not just for creating images, but for editing them as well, to change the colors, to change the parts of the images, to delete the background. So it's advanced image editor right now, and you can use it for several tasks. And this is the one of the example, and you can see it's even better than Photoshop for this exact task. Also for video, for example, you can make your image live like that, for example. This is the pretty interesting. And this is the project, the competition project, and the images itself I used here, it's real renders from Blender, but I used the static images with ComfyUI to produce this video. And this pretty good video, I would say. So it's not a totally not the same, which you can create in the proper for the proper animation workflow, let's say, but it's fast. So you can just you only need your images, and then you can use this algorithm to create video like that, and without the real scene, without the real animation work. So it's sometimes worth it. Also for renders, this is pretty obvious. So you can upload your screenshot from the 3D software like that, and then make a render. And also, even if you don't have 3D scene, but you have sketch, for example, or something else. For example, this is the sketch from Mr. Prix, who is the head of ComfyUI, and this is the model which trained on the ComfyUI projects. And you can see how this model can handle the sketch to the actual image, which is also pretty interesting. So for that, of course, you need to train your LoRa's, and this is the complex workflow, how to train it. Exists different tools for that, different approaches for that. And this is the huge topic. We will not go into this today, but maybe next time. And this is the example how I trained the model for Flux on top of the ComfyUI dataset. And this is the images which were produced through this model afterwards. And you can see some ComfyUI style here. So, but it's not an actual project. It's just an images. And this is the page on cvti.com where you can find some models which I did. For example, this deconstructivism model, or for example, I don't know, this geometric minimalism, also mine model, and some this also mine. And this is my collection actually, the models which I used for different ComfyUI workflows, and some of them my own models, some of them from other architects. For example, this Nunu model from Ismail Salat, and some models from my students, for example, these two. And this pretty cool model, and also this, for example, from made by Kas Espan, and this also nice model. So you can download them from this website and use them for your own workflow. It's totally free, so you can just go to this website. And this is my Instagram, if you're interested, so you can join. And this is my name on Instagram. And also I have a Telegram channel, this one, where you can find the algorithms for Grasshopper, workflows for ComfyUI, everything for free. So you just need to join and download them. So this is 2 pages. And before this is the end for presentation actually, and before we start the workshop itself, I would like to share this folder with you. Just a moment. So anyone? Cool. And I put this link to our Zoom chat. Please download all this stuff. It's necessary for the second half of our workshop. So mainly this is the workflow itself and several models, most of them LoRa models, which you can find on this CVTI page, and also other models from CVTI. But to simplify this process, not to give you a lot of different links for downloading, you can find all of them here. And this is the one source for all these models which we will use today. Also, if you didn't install ComfyUI yet, so this is the simple approach and simple installer. I also copy it to the chat. And ComfyUI launched this desktop version. It's actually a beta version, but it's working well. You just need to launch this installer and install it. They opened it last week. It's totally new. Before, you need to install ComfyUI in a pretty complex way, but right now it's like a regular program. So you need to go to the installation part. So it's somewhere above, I suppose. Just a moment. Yeah, here. So for downloading, go to the setup instructions, and this is the Windows version, and this is the macOS version. Just download it and double click on the installer, and then follow this instruction. But more or less it's pretty simple. You just need to pick a folder and install it. So this is the whole idea. It's also pretty fast for install all this stuff. Where you need to put all these models, I will show you on the second half of this workshop. And that's it for introduction, I suppose. And so I don't see any questions. What is the name of the plugin? It's already answered. And so let's switch Stepan again, and then we can start.
Thank you, Alec. That was amazing. I'm happy to be here on this webinar with you. I have a quick question for you. Do you think that all those AI workflows and AI models and tools are ready for really detailed project development, or are they mostly for concepts nowadays?
So it's a lot of tools, actually. It depends on what you would like to use. And we are using, let's say, several of them. And for example, tools like Midjourney or Stable Diffusion is better to use for concept design, of course, because it's mainly for that. You can produce interesting concept and renders, and it's not for detailed development. But ChatGPT, for example, and similar language models like Llama or it's lots of them actually, you can use even for the detailed design inside of the Beam model, inside of the Rhino, inside of the Blender as well to code something. You can even make an approach where you have bunch of agents, AI agents, who working together, and you only make your input for the first agent, then this first AI agent produce something, and then the second, for example, check it. It's proving it's okay or not, it's fine work or not, and you can make this chain of agents to produce the nice result, and it's possible even right now. So it depends on what you would like to do and what exact task you would like to give them, but in general it's possible to use them at least.
Okay, cool. Yeah. So we are asked to share download link in our chat. Can you copy the link itself, not the Notion link, but the download link as well?
Okay, I will do it. You can start your part, and
Okay.
I will copy the link for downloading.
Okay. So let's talk a bit about software development and web design. Kodiia is a platform that me and Macaulay Kalina started working like several years ago when it was a pandemic time, and we were hosting various online workshops, lectures, and webinars, mostly connected with coding and creating some kind of architectural web tools. And we came up with the idea that we could make our own platform to make everything easier for us and for students as well. So this platform started as a set of interactive tutorials that you could follow along with step-by-step instructions. And later it evolved into an online code editor where you could save your projects, you could talk with AI, and we actually implemented the multi-agent system here. And nowadays we have a more advanced version, which is in a demo right now, where we implement more AI tools and various AI models into a single UI environment. So basically, if you go to Kodiia website, let me open this. Yeah, you will see something like this. This is the available version right now, just online code editor. The screen is split in 3 parts. The left part is for files and data of your project. The right part is resources with tutorials, challenges, different AI hints and stuff like that. And the central part is basically the project you're implementing and working on. And if you click this green button, you'll be redirected to this page. Basically, for today, it's not necessary for you to sign up. You can just click necessary templates that I'll be showing and hit this open sandbox button, and you will be redirected to a page like this. And let me show you what we are going to do today. So our final point of the first half of the webinar is an app that works like this. You have simple UI to control the basics. Control the grid, for example, colors, and control the simulation process. And you can also save a screenshot of the canvas that you can use later in the ComfyUI workflow. And you also can export the geometry that you create here as an OBJ file. And we'll be going through all these codes, discussing all the commands and what is going on here. But we'll start simple, so no worries if you have never tried coding before. By the way, it would be great if you could share in comments in chat. Are you familiar with web design, or is it your first time ever? That would be great for me. And okay, the right part of the screen, let me move myself somewhere. The right part of the screen is basically some pretty generic description of what is Cellular automata and what is exactly the diffusion algorithm here, and what you can do with this. Okay. Okay. Okay, do we have somebody with super advanced knowledge of coding, full stack developers, backend, front end, something like that? Seems like most of you guys are doing it for the first time. All right, super cool. So let me know one more thing. If you sign up for the platform and you go to the starting page, you'll be able to click this create button. This button lets you create your own project with a template. Let me just, okay, let me use the 3JS template, hit create button, and let's see. Okay, we have guys familiar with JavaScript and Python. Pretty cool. So if you sign up and you will be able to create your own project, you will have the same layout as before, files on the left, but you also have an option to upload your assets and data, and you have this chat section on the right, as well as different tutorials available and challenges as well. And you can ask anything like, I don't know, how do I create a button in HTML. And we have several language models. They work as kind of collective. One of the models is an artist, and it helps you with some basic design ideas, coming up with the concept, the idea description, something like that. We also have a coding agent. He helps you writing some examples of code, and he also comes up with some further suggestions what you can do next in your project and so on. And we also have a communicator agent that comes up with some questions to clarify your request if something is not clear enough to the agent system. And this is what we have now. Okay. Then again, we are here to have fun as well. And of course, you can use the code that we are creating here. You can just copy paste it to any platform that supports creating web projects. You can even run it on your computer as well, locally. Just hit the download button, for example, here if you create a project, or just copy and save it as a file with the same names as here, and same, how do you call that thing? .html, .css, .javascript, and so on. If you are ready for some experiments today, I can show you the beta version we're working right now. This thing looks a bit different, but it provides you more options to work with. So it's more than just a code editor. You have various options of what you can do here. You can basically chat with the model. For example, you can ask it like, working on a concept of a 15-minute city project. I want to use Cellular. Okay, like, what is it? Click send, and the model will comes up with the answer. It will tell you about the 15-minute city concept, and with some data as well. And later you have some options. After every step that you take, it all represented as a thread on your screen. So just step by step, like a chat interface. You can, for example, hit create an image. It will grab the description here that was discussed and will create an image like that. And we use different kind of models, and then with the image you can either create a new image or use the vision model to discuss what is going on in the image. You can turn it to video, or try turning this image into a 3D model, for example. And you can also download this image or delete this chat section, for example. And we also have necessary code templates here. So if I want to open the code templates that we're going to create and use here, I can open it here as well. So I'd be super happy if we could try this thing. but this thing will work only if you sign up for Kodiia platform, or we can just stick to the available version right now. What do you think, guys? Should we try something really in development right now, or should we stick to something more time proven? Okay, we have some brave people. All right, cool. Then I'll share the link here as well. Okay, some want the safe version. We can do both. Implementation of ComfyUI in this chat interface, you mean? It's technically possible to use ComfyUI workflow in a web app. You can export it as a JSON file format, and then you can use special resources to implement it here. But this feature is not supported by us yet. But yeah, if we technically it's possible, but we haven't done it yet. We will try in the future, probably. All right, so I guess I'll be using this version today, and I will also be using this version as well. So nothing special, and you can choose whatever you want. So nope, you don't have to use stable diffusion account and nothing like that. We even don't, as we're still in development, we even don't record the amount of requests you use to chat with various models. So basically, you have unlimited amount of image generation requests, video generation, and stuff like that until we ran out of our credits with the providers that we use here. I guess that all the links that we share here, you will be able to find in your email later on, definitely. It's not a problem. So, first of all, let's start with some web design things. When we talk about web design, there are three basic technologies, I guess, that we have to mention. The first one is called HTML, which is short for Hypertext Markup Language. And this is basically a markup language, not a programming language. It's something that you use to tell the browser what you want to see on a web page. Some text, headings, images, and so on. And if you open this static template, for example, it opens Sandbox in safe version. What was, yeah, safe version. Let's call the black UI the safe version. Or if you go to the code tab here and hit static button here, okay, why is it undefined? Go back to this. Here, okay, static. Okay, yeah, if you hit static, here you will be presented with the same projects. So what we have here, we have 4 files. Whoops. Sorry. We have 4 files. The first one is called index.html. This is the main file of any web application. Everything in your browser starts from here. This is the first file browser gets. This is the file that is used to understand what other parts of code should be displayed on your web page. And it's basically responsible for the structure of the web app or web page that you're developing. HTML consists of things that are called tags. These are just those blocks of code between those arrow symbols, arrow brackets. And every HTML document should contain several necessary parts of it. The first thing that we will see in any HTML document is the phrase that it's doc type HTML. It just says that everything written below is an HTML document. Then we have HTML tag specifying what kind of language we use here. And inside this HTML tag, we have other tags with the necessary data in our web page. Those tags are separated in 2 parts. The first part is called head, and let me get it like this. The first part is called head, and it is used mostly for technical details, like what kind of libraries we use here, where do we get them from, what kind of other files we use here, like style files, and so on. And this part located within those head tags is mostly used by robots, for example, that are searching the web, trying to rank your web pages and to understand what kind of content is represented on your web page, and what kind of search requests should be related to your web page, and so on. And the second part is body part, and it's located between 2 body tags, and this is the part that we exactly see on the web page. So, for example, here in our static template, we have a heading tag, which is created with tags like H1, H2, H3, 4, 5, and 6. And we also have some paragraph part here, which is created by a P tag, for example. P is short for paragraph, H is short for heading, and the numbers in headings are representing the importance of this heading. So there is a title, for example, there is a subheading, just heading, and stuff like that, and they are mostly representing by those tags with different numbers. Some tags are used in pairs, like those body tags that we've discussed, like HTML tags or head tags that we've discussed before. But some tags are used on their own, just without any second tag. And if you want, you can go to the link here, HTML elements. And this is the link to, let me copy it to you, with a list of all HTML tags for various tasks. So, for example, there are separate tags for images on the web page, separate tags for videos on the web page, for input elements like colors, passwords, and stuff like that. Basically, there are a lot of different HTML tags nowadays. HTML appeared in 1989, if I'm not mistaken, somewhere there. And now we use HTML version 5. So it kind of evolved in 30 years. And now we use the version 5. So, and some more tags appeared from version to version, and you can just take a look at this and see what tags are used for what tasks, what are they responsible for. So for example, if you want an image, you should use an img tag, for example, here. And if you want to create a button, you should use a button tag, for example, and this will create a button, but not like this. Basic button looks different way. So here in my static template, if I just type button, it's a tag that's used in pairs. Some text that you want to see on the button, you have to type between the tags. So here I am having this start button on my web page. And the same thing in this, go full screen. The same thing. Just make a background. Okay. The same thing happens here. You just type in button. You just type in some name here, and voila, you have your button here. The second part of web design projects is called CSS, which is short for Cascade Style Sheets. This is the part responsible for the way things look on your web page. So for example, here we have a heading and a paragraph, and we have some styles for them. And if you look at how CSS looks, you will see that the syntax is different. We don't have arrow brackets anymore here. We have curly brackets here. And we have references for the elements in HTML documents or selectors. And for example, we had an H2 tag in HTML file, and here we have H2 selector here. We had a P tag in HTML file, and we have a P selector here. So we just type any kind of selector name, then curly brackets, and then some properties that we want to set up. There are various different properties. So for example, if you go to this page, you will find different kind of CSS properties and selectors as well, how to set up color of elements, how to set up sizes of them, and so on and so on. And for example, here we have a color property for our text, yes? And this means the color of our text. So if we change and hit run again, for example, you will see that your text now has a different color. And if you go to CSS file here as well and change to any color, you'll also see that you now have text of a different color. And this is just like a single property, yeah? If we want to change fonts, for example, we will use a property like font family. Font family specifies the family name font family, font name that you want to use in your project. And there are specific font names, like, for example, Arial or Calibri or Times New Roman, something like that. And there are more generic names that specify the group of fonts that you want to use. So, for example, there are fonts named serif, and these are type of fonts with more looking like an antique kind of font, like Times New Roman, for example. Sans serif group of fonts is a type of font that looks more minimalistic, more modern. It doesn't have those, I don't know how to call them, ticks on letters, for example. It's more minimal design. And there is also a special group of fonts which is called monospace. This type of fonts is mostly used in code editors, for example, where you have every character the same width as any other character. So here in the monospace type of font, letter I, for example, takes the same amount of pixels as letter W, for example, or letter C. And it differs in other font groups. So basically, when you specify just like a font group like this, the browser itself goes to your system properties and comes up with the most suitable font that is located on your computer. And of course, you can use custom fonts in your projects. For example, there is a thing like Google Fonts, fonts.google.com. Let me try this one. So you go to this page, you select some kind of font that you like here, like for example, I don't know, let me take this one. You can try various options for this font, and you also have get font button, and you can either download this font or you can get this embed option to use it directly in your code without downloading it on your computer and then on the server for your web page or web app. You can just use a link to a font. So for example, this import option in the web section here will provide you with a link that you can copy, then go to your CSS file and use it on top of your CSS file. And the next thing we need to specify is this font family option. And yeah, every line in CSS should be ended with a semicolon. So in our font family, we can use now this data that we copied from Google Fonts. Yeah, and now we have this font in our project, and it works fine. So every time the browser loads this page, it goes to this link, downloads the font, and then displays this font on your web page. Let me make it not so red. Be blue. Yep. Okay. And it doesn't matter if you use the safe version or if you use this version in development. you have this save project option here. But before you save project in this development version, you should specify the name of your project. For example, this test project. Then you hit save project. We'll try to save your project. And in resources tab, you have a project tab, and you have this latest project on your own that you have just created test. And if you hit preview, it will open a new tab in your browser, and you will have the link to your project that you can just copy and paste and share with your friends, for example, saying, look what I've created. And the same thing happens with the save version. Only let me find the project that I was creating. Yeah, you have this save button here, and you can specify a name here, hit save button, the page will reload, and then in the project section, this same button, projects, here as well, you can click like share, for example, and you will have various options to share this project either with the link or directly to a social media or an email, for example. And we will add this functionality in the development version as well pretty soon, I guess. So, okay, so we have a button here on our web page, for example, but it's not doing anything. In order for the button to work, you need to use the third part of any web project, which is called JavaScript. And JavaScript is a programming language. So HTML and CSS are not programming languages, and JavaScript is a programming language. And it was, I guess it appeared in 1995, something like that. So basically when HTML appeared, it took a few years before they started kind of looking for ways to, and basically initially HTML was just a way to link documents located on different computers in the same network. And the initial idea of HTML was using hyperlinks. So you could click a link in one document and open a different document located on a different computer on your machine. That was the idea behind the HTML. Then they started searching for ways to make documents look prettier, and that's how CSS appeared. And later on, there was a search for making the documents more interactive, and that's how, I guess, JavaScript appeared. But I may be wrong here exactly. So basically, it appeared in 1995, something like that. And first, it was called ECMAScript, which is the original name of this programming language. But due to the marketing necessities, Java was pretty popular during that period. And the guys that were using the new language decided to go with the name JavaScript just to kind of use some some part of popularity of Java language. Yeah. So when you are working with JavaScript, you can do different things here. Let's try, make something with the button. In order to make the button in our HTML document interactive, we have to apply, we have to name it somehow to make this element unique, and to provide this unique name in our JavaScript document so that we could kind of connect two separate files together. So this unique name is called ID, and different tags in HTML have different kind of attributes, and you can provide ID attribute to any tag. You just have to make sure that this ID is really unique, so that it is not repeated in any other tag on your web page, in your HTML document. So I have a single button in my document, so I can give it an ID like button, and that will be enough. Okay, then I have to go to script.js, and here I can create a variable. Variable is a thing that is used to contain some data. You may think about it as a box that contains something. It may be a word, it may be a number, it can be an image, 3D models, something, anything. So I will call my variable, I'll start calling with a special keyword. It can be either const or let, or there is also a var option in JavaScript. And they have different properties. So in our case, this variable is not going to change its data during the time the program is executed, at the program that we are doing. So we can use this const keyword, which is short for constant, I guess. And we can name this variable button as well. And in order to link this variable to a button that we've created in our HTML document, we should use a command like document. Then we can type get element by ID. And here in the braces, in quotes, doesn't matter single or double quotes, you just specify the exact ID that you used in your HTML document. So here we have a variable, and this variable now contains and connects to that button tag in our HTML document. So we now can make something with this button. We can ask it to do something, and for that we should type the name of the variable. Now we are using this variable to make some actions with the button. Then you can type add event listener. Event listener is a thing that attaches something that is listening to events that happens to your button. It can be various types of events. You can listen for a click, for example. Here we're going to use the click event. You can also use like mouse over or pointer over, pointer out, pointer move, and stuff like that. So basically there are various type of events that you can look for on your web page and then trigger some actions based on these events. So here we're using the basic click. So when we click on our button, we can make something, and here we usually specify a function. And there are different ways you can do this. So we now created a variable. Let's create a function. Let's look at the function as well. Let's come up with the name of this function. So for example, this function will change the background color on the web page, and I will call it like change background color. So just type the name of the function that is not existing yet. So in the next line, I can say a keyword function, type in the name of my function, change background color, then add some braces and curly braces. And between them, I will say what exactly are we going to do in this function. So we are going to get document body dot style. Body is the name of the tag in HTML file, and style is the collection of CSS properties that we can get access to through JavaScript. So you can say body.style.background equals, for example, okay, pink. And let's try. Okay, now I have a button, and if I click it, I now have a pink background on my web page. So what we did now, we kind of connected our JavaScript document to our HTML file element using a variable and a special command, document get element by ID. So it says, go to the HTML file and search for an element named button. Then attach an event listener to this element. We used for this add event listener command. We use this click event that we're searching for, and the name of the function that is going to be triggered when we check for this event. When we click on our button, we're going to execute a function named change background color. And then we just wrote this function using a keyword function, using the name of this function. Now, those brackets are used to specify some arguments or some specific data that is going to be used inside this function, but we don't have anything for now, and we don't need this, so we just leave it empty. And then between those curly brackets, we just type what kind of actions do we exactly need to produce. And voila, we have our button working. So if you're using this version, you can, for example, let's delete unnecessary data here and this text as well. And in your chat section, let's try to this, ask some question. Okay, like, how do I make a button that will change my page background to a random color anytime I click it? And you can just hit send, and the model gets all the data from the files that you have in your project and whatever discussion you have on your page. And here it comes up with a solution for the task that you've provided. So what it says is you should use an ID, yes, as we did before. And let's add an ID here. And then it provides us with some JavaScript code, and you can see that this is the JavaScript by this icon and this HTML letters and JS letters here. So what do we get here? We create a variable, we get element by ID, the same as we did. We add an event listener, the same as we did. And it also comes up with the second function, which is called getRandomColor, and it just creates a random values for RGB values. And do you guys know what RGB is? Yep, all right. And then it comes up with the second function, which basically gets the new color and applies it to the body the same way as we did. Let's try. Just copy, go to the JS file, and replace, and okay, and anytime I hit start button, now I have a different page background. Okay, I guess that this is it for a brief introduction to web design. Our next topics are 3GS library and basics of using 3D in the browser. Yes, you can build the front end with this. And basically, what we have here is the way to create simple front-end applications. We do not have any complex database implementations available here yet, but we're thinking about it. But yeah, anything front-end is possible. And as for the models that we use here, nowadays in this demo version, we have a model Llama 3.1, if I'm not mistaken, which is 405 billion parameters. And in this version, we have 70 billion model. And of course, we have different models for images, vision, and so on. So yeah, do we need a break? Like a 5-minute break just to get some water or anything? Or we can continue. How do you feel, guys? Okay, okay, if you feel like you need a break, just tell me later on. So let's dive into 3GS. For 3GS, we have a separate template. Yes, what do you mean? Yes, you need a break, or yes, we can continue. Oh, so you're worried about me. Don't worry about me. I'm more worried about you. I'm okay without bothering. All right, so let's continue. And our next template that we're going to use is 3GS. Okay, and if I go home and I click 3GS, open sandbox, open script.js file, hit run. Yeah, I have this white cube and I can rotate, get closer using my mouse and mouse wheel. So you just zoom in, zoom out. You can use your right button on your mouse or left button on your mouse to produce various options. Basically, it's just panning, zooming, and looking around. Okay, so let's try to understand how this thing works. Now, 3GS is not that simple. And the 3D in the browser is not that simple. And 3D in game design is not simple either. So it's going to be a bit more complicated. If you go to 3gs.org website, you will see various examples of what you can do using 3GS library in the browser. And what is a library in JavaScript? It's the same as a plugin in Grasshopper. You just import a library into your HTML file or directly into your JavaScript file to make some specific actions. And there are different libraries for different actions, the same way there are different add-ons in Grasshopper for different tasks. So 3GS is mostly for working with 3D and creating shaders and stuff like that. But you can also use it to create augmented reality, virtual reality apps. And yeah, just take a look at the website when you have some time. Usually I show this example. Was never like this before. Okay, it works now. So there is a company named Faraday Future, and they create electric vehicles. I don't know if they exist yet. I hope so. So they kind of created this virtual demo where you can control the car using your keyboard, and it seems like it moves somewhere. I'm not sure that it's moving. I guess it's just an animation and some kind of you just have a feeling that it's moving, but I guess in technical terms it should be something different. At least we don't see mountains rotating on our horizon when we are rotating in our car. But anyways, you have a decent 3D model with decent materials, and you can control the lights of your car. And yeah, you can just take a look at this model. This is example number 1. And there are more of them, of course. And they have pretty cool documentation. So if you need anything, it's pretty detailed here. But some people say that it's pretty detailed for some basic experiences. And if you need something extra, it gets pretty complex. I don't know, maybe yes, maybe no. And there are a lot of different examples. So this one, for example, is a scene created in Blender with some animations created in Blender, and it then just imported here in a web project, and everything just runs in your browser. It's not that hard to import it in a browser once you have everything working in your Blender file, and it was modeled with an idea that you should control the amount of your polygons. So if you have not that much polygons in your 3D model, you're fine to use it in a browser. But there are also ways to compress models and stuff like that. Anyways, working with 3D models in a browser created in Blender, it's a different topic for a different workshop or a webinar. There are tons of examples here. You can create different kind of materials like those. I don't know, these are just balls that look like drops of water hovering in the air, and you have an HDRI map in the background, and everything reflects and so on. You can have, you can create something like in Minecraft, for example, and you have different options to control how you move in this 3D space. So for example, in our template, we use a thing called orbit controls. It lets you rotate your scene, zoom in, zoom out, and pan. And here they use a thing called fly controls. Basically, lets you fly around, boom, where you can get through objects. But then again, it depends on how you create your scene. So you can Gaussian splats. Is it possible to implement Gaussian splats? I've never worked with Gaussian splats. How big is the file format? Is it a cloud of points, or is it, what is it? Is it a mesh geometry, or is it just a lot of points? COY. Okay, let's check. There are different file formats that you can import here. So basically, if you have a PLY file, you have a special loader that lets you upload your model in a web browser. So you should just use a specific part of 3GS library to use with this file format. But yeah, you can take a look at the examples, and in the right corner, this lower right corner of your screen, they have a button, and it will get you to a GitHub page with all the code. So you can look through it and take a look what's going on here. So basically they use this PLY loader, provide a link to a model, and this link should be to some kind of storage that is available online, so that the browser could download it. And then they kind of use some special commands to set up a material, to create a mesh, and then they kind of add this mesh to a scene. And there are various models that they use here. So yeah, take a look at the example. And different file formats supported. Okay, what else can we take a look here at? Different kind of lines, for example, not only 3D models, but you can create lines as well, fat lines, dashed lines. You can raycast, so you can just get the intersection points with lines, and kind of, if you want to, for example, make them interactive and make them, well, if you want to click them and then execute some action, for example. Basically, the most used format in web is called GLTF or GLB, and these types of files are exported from Blender, and you get quality like this. So if you set up all the materials in your Blender file properly, it all works like this. Okay, let's go back to the code. So the first thing we need to do is to import this library in HTML file, and you can find this data in 3GS, documentation, installation, I guess. Yeah, and we're using here an option import from a CDN. You have to provide some script tags with some links in your HTML files, and then you have to import the necessary parts of the library in your JavaScript file as well. So in our case, we provide those scripts. And in our JavaScript file, the first thing we do is we import the 3JS library, and different parts of library may need some special import in case, like with this orbit controls thing, it needs to be imported separately. And the same thing happens to different kind of loaders, like PLY loader that we just discussed. Yeah, basically you just copy and paste from the docs section. What do you want me to show exactly? How I can copy paste from the docs section, or how can I open this template with the created code? Okay, so you grab this part with the script section, and you can see that this is HTML because of those arrow brackets here, and it is written here. We need to add an import map in our index.html file. So you just grab this, Control-C, go to your HTML file, and in your head section, the technical section that I was talking before, you import this data here. And that's it. Or you can just open a different template with 3JS that we have available. Especially for you, this one, 3JS, basic theme, and just copy paste all the code from there. And the next thing is your JavaScript file. You need to import this library here as well, and all the necessary extra parts that you want to use in your code. So in order to see something in your browser window using 3JS, you have to create several things. Number one, you have to create a scene. So basically an empty space where everything will exist. And this is created with a command like new 3.scene. And usually you just use a variable named the same way, scene. So everything else will be added into a scene. The next thing we create is a camera, and there are different types of cameras, like perspective camera, orthographic camera, and stuff like that. You can read more in the 3JS docs about it. And you provide some basic setups. For example, 75 here is the angle of your camera, how wide or how narrow is the angle that you're looking with at objects in your scene. This window will inner width I forgot how this math action is named in English, sorry. Divide, yeah, divided by window inner height. So this line sets up the pixel ratio of your image, basically. This 0.1 number is how close to the camera objects are visible. Yeah, so if they're closer to the camera than this distance, they will not be visible. So basically, the next number, 1000, is how far do we see with our camera. These are just some basic setups that you may find in Blender as well, and in any other 3D software, I guess. And then we move our camera a bit. And an important part here is that the y-axis in 3JS is the vertical axis, while x and z axis are horizontal, apart from other software 3D tools. where the z-axis is the vertical one. So then we kind of get our canvas element from HTML file. In our HTML file, we also have in our body a canvas. It's a special tag to contain different kind of graphics, whether it's 2D or 3D. It usually goes into a special canvas element. And the next thing you have to set up is called renderer. This is kind of a tool that will reduce an image of what is going on in your scene, looking at your scene through the camera that you have just created and the exact position that you set up. So you have you can provide different properties here. You can provide a canvas element from HTML file where it will output an image, like a screenshot of your scene. You can provide different setups, like anti-alias is a command that prevents your image from pixelating. It makes it more smooth and more visually good looking. So set size is basically the size of the image you want to output. We basically take the size of the window in our browser, its width and its height. Pixel ratio is how dense pixels are. Okay, it's just a command to set up the quality of your image. As much with this line of code, you use as much pixels as possible on the exact device that you're using. So if it is, I don't know, an iPad with a certain amount of pixels on the screen, it will use its setups. If it is an old, I don't know, monitor, an old screen with different pixel setups, it will use the best option possible to display your image in the best way. Okay, so shadow maps is for shadows. Output encoding is some setups for the colors of your image. The same goes with tone mapping. You can read more about this in the documents of the library. And I guess the last most important thing is this function animate, which is kind of a game loop, because it calls itself in a loop, and that way we can see animations on our screen. So basically renders your scene frame by frame, and anytime you rotate something or something moves in it, you see it just because it's a constant sequence of images rendered on your screen. And then, of course, we need something in our scene to see. So in order to set up lighting and shadows, we create those lights. There are many types of lights, but two are the most basic. The first one is kind of an ambient lighting, and it's called ambient light. And just a light source that goes from everywhere in your scene, and it illuminates the objects from everywhere. And here we use a special light called hemisphere light. It's the same as ambient light, but with ambient you can set up only one color, and with hemisphere you can set up color for the upper part of the sphere and the color for the lower part of the sphere. So you can set up some kind of a sun illumination from the top and some I don't know, extra lights from the ground plane, something like that. Or you can just play around with those two colors and see the results. And then, of course, there is how strong the light is. This value controls how strong the light is. And anytime you want to add something in your scene, you have to run scene.add command and then specify what kind of object you want to add to your scene. So if you created all the setups for your light and then you forgot this one line of code, nothing will work. Just make sure that you do not forget this line of code. So the sun is created with the directional light. And directional light, here we specify the color and specify the brightness of the light, specify the position of our sun, and we also add some shadow setups. And yeah, shadows are, there are a lot of different commands for shadows. Basically, you have to set up the zone where the shadows will be rendered. They are not rendered in the whole scene for the sake of saving computer resources like CPU and so on. So you have to provide exact setups for shadows. I'll skip this for now. It's not so important for the sake of today. Another important function here is called resize. This one is responsible for changing the size of the image that renderer produces whenever we change the size of our window and browser environment. And of course, we need to add some geometry to our scene. And in order to do this, we have to specify three things. We have to specify the type of geometry that we want to create. So in our case, it's just a white box. So we specify box geometry with some data like what kind of what size, yeah. So it's like 1, 1, 1, and if we change it, for example, to a different thing, you will see that it changes also. So basically, the size of the box you want to create. Then you have to specify a material. There are different types of materials as well. So the standard material is a material that supports lights and shadows. And you can specify colors here, and many more set options are available. And the third thing you need to do is to create a mesh itself, and the mesh is created with the geometry and with the material, and it all goes into different variables with different names that you can come up with. And do not forget to add all this in your scene. And then we have those controls, the thing that helps us rotate our scene, zoom in, zoom out, and pan. And we have to import it separately as well, as we did in the beginning. We just imported separate, like a block of 3JS library. And here we have to use it. So we have to create a variable. We have to set up some options, like target option is where it is the point that we are rotating around. Then we have to set up the distance for maximum zooming out, zooming in. You can set up different angles for rotating in your scene. Again, there is a lot of data in the documentation. And that's it. And then you have to run the animate function in order to see anything on your screen. These are the basic setups for 3JS scene. So here we have a white cube, yeah, and why it's white? Because we have a white property in our material. So if we change it to blue, for example, you will see a blue cube. If you change box geometry to, let's take a look. What kind of geometries do we have here? cameras, extras, all geometries. So these are all the options available: box, capsule, circle, cone, just some basic 3D models. So for example, sphere, let's change our cube to sphere. Here is sphere geometry. 153216. Let me change this box to sphere, and let's say 232 32 and then 16. See where it goes. Yeah, now we have a sphere in our scene. And if you want something more complex, like this stuff, for example, you have to model it somewhere and then import it as a 3D model in your file. And of course, if you're using this demo version right now, let's delete our previous talks. And for example, you can ask something like, how do I create a pink, for example, torus node in my scene? And you get a result like there is a special torus node geometry. Okay, let's try this. So we have a cube, we have controls. Let's add torus node, and we have like a different object here, and we have a different material. What kind of material is that? It's mesh standard material, and the AI model also added some extra properties like metalness and roughness, and you can see that this thing looks more shiny than our basic cube, for example. And also AI suggests us to rotate the node, and you can, if you want to, you can add those rotations in your animate function. And okay, this is just a rotation. If you want a simple animation, you can do something like that, and you will have a rotating object. Now, maybe this is too much, like 40, 40. Yeah, now we have a rotating object in our scene. So we just added some kind of animation using our animate function. And as I said before, this function just renders like an old Disney cartoon, like frame by frame on your screen. And it all depends on the screen type that you're using. So if it renders 30 frames per second, the thing will run with 30 frames. If it renders 60, then it will run with 60. And the same code with the same animation will produce different effect on different devices, because it all depends on the screen type that you're using. And in order to do to make the animation the same on different kind of devices, there are different tricks, like using calculating the delay between frames rendered on the screen, and using this delay in order to calculate the necessary rotation angle, for example. It's a different story for a different webinar and different workshop. But yeah, so in your okay, so the next part that we're going to dive into is using 3GS to create a 3D cellular automaton. And you can use this diffusion template, the last one that is added specially for this workshop. And okay, so you can open it here as well. I don't need this text anymore. Let's try and open it as well here. Will it work? Yeah, it works. So what do we have here? We have our HTML file, just as before. We have scripts to import the 3GS library, the same as before. And we have some extra parts. The first part is canvas, the same as before. The second part is the menu. Just some HTML elements for the menu that we are going to use. So the menu consists of different elements. For example, input elements that you can use to set up the grid size that you're going to use for the simulation. So we have a 3D grid, so we need 3 inputs, and each input is responsible for the width, the height, and the depth of the grid. In order to create this, we use 2 HTML elements. The first one is called label, and it's responsible for creating this text. And the second one is called input, which is used for inputting something, some data. There are different types of inputs. For example, when you were logging in or signing up for a platform, you used an input of a type email to provide your email, and you used an input of a type password to provide the password. Here we use inputs of type number to provide some numbers, and we also use inputs of type color to create some colors. And basically, this is it. We also use some buttons to either update grid if we change some sizes, some numbers here. You can click update grid and you will be provided with a new setup for the simulation. And we have some numbers to calculate the next generation of our simulation, to save the screenshot, and to export an OBJ file. Okay, so the HTML part is quite simple. I hope so. We have some styles in CSS here as well. Mostly what they do is the whole menu is located in a div element. Div is an element to group different kind of elements in a single kind of a frame or a box in HTML. And if you take a look in your HTML file, you can see that this div has a class attribute. Before we were just discussing ID attributes, which are useful when you want to make something interactive with JavaScript. And this class attribute is useful if you want to style multiple elements with the same properties. And our class attributes are in CSS are starting with the dot. So in order to provide styles for menu class in HTML, we have to type dot menu in CSS and then provide some properties. So here, what we do is provide absolute positioning so that we see our menu part on top of our canvas. Other ways, if we do not specify these properties, we will not see our menu, as it will go either below the canvas and you'll have to scroll up and down in order to change something, or it may go behind your canvas and you will not see any buttons at all, as they will be covered by the canvas itself. So this is necessary just to position elements on your web page properly. And of course, there are different types of layouts you can use. Here we just use some standard basic layouts, but also you can use like grid layouts if you want to structure your menu elements in a grid-like way. And there are special layouts like flex, for example. But again, I guess that this is a topic for a different workshop with a more in-depth view. Anyway, you can ask AI about flex or grid layouts if you want to. We have also some styles for buttons here, and here we just reference a button element from any button element in our HTML file, and we provide them with some special properties like margin is the distance from this button to the next element on your web page. So 5 pixels is that is the distance between the border of the button and the area of the next element on the page. The background color is the background color of the button. The color is the color of the text on the button. Border and border radius are properties describing the border of the button, its width, and the radius of the corners and stuff like that. Padding is the property that describes the distance between the border and the elements inside. So basically, the distance between the border and the text that we have on our button. And cursor.pointer specifies the cursor look on your web page. So if you drag your mouse around, you'll see that when you hover over the button, it changes to this click action icon. And then it just arrow again. Label those white inscriptions here, just provide color. Inputs are all the fields where we can either input a number or a color, some properties for them, and some specific properties for inputs that have type color. Those are the styles that we have here. The next thing is our 3JS file. Okay, we have here like 250 lines of code. Most of them we have already discussed. It's just basic setups for your scene, like scene, background, camera, renderer, lights, resize function, animate function, using orbit controls, and so on. And then there are some more functions and more logic that we use in our scene. So for this workshop, we decided that in order to somehow arrange all the software topics that we're covering and connect them with architecture, we will use this idea of 15-minute city, which basically describes a city where you can get anything you need within a 15-minute walk from where you live. So if you need a shop, it is located within a 15 minutes walk distance from where you live, and so on. This is the basic description of a 15-minute city, and it's not only walking, but also 15 minutes by transport, 15 minutes by bicycle, for example, and so on. So there are layers in this concept. So we thought that we would kind of generate kind of a structure that replicates this idea in a 3D form. Where would we change the cubes to torus? The cubes are changed whenever you set up the geometry for cubes. So in your code, you have a line like geometry equals new 3 box geometry. So instead of box geometry, we use torus knot geometry and provide some specific setups for this type of geometry. So if you want a different kind of shape, a different kind of form in your application, instead of box geometry, you set up something else. Okay, and to generate something like this, the diffusion algorithm of Cellular Automata is pretty useful to my mind, because we can set up some basic points in our grid that will contain kind of the starting points, and then we will grow our city or city neighborhood around them. So just pressing next gen in this application, you will kind of see how the 3D form spreads, starting from those red boxes and then proceeding to those blue environments. And you may think about this as some kind of mixed use activities. I don't know, some offices, shops, shopping malls, anything, gyms, and so on. And then those blue parts are maybe residential areas, for example. And you kind of locating all your residential areas between those public attractions, and you kind of creating this mixed use and balanced areas. And diffusion algorithms are mostly used to simulate something like fluids or gases, and it how it works, it takes okay, we'll cover it in a minute how it works. So do you guys know what Cellular Automata is, or it would be better if I briefly describe the idea behind this? Okay, everybody's silent. So Cellular Automata is, let's start with a simple sketch. Okay, so imagine you have a grid. It's an old concept. This concept was developed in, I guess, 1940s, 1950s. And it evolved later and got implemented in various fields from biology to video games, and is used for complex simulations with simple set of rules. So you have a grid. It can be a 2D grid, it can be a one-dimensional grid, for example, or a three-dimensional. A one-dimensional grid is something like this, just like a line of cells, and then it evolves, and you kind of, in the next generation, you just draw this line a bit lower, and so on, and you get different results based on this approach. So a 2D grid is a 2D grid, and a 3D grid is a 3D array of boxes, for example. So every cell in the grid has its state. It can be either alive or dead. For example, this cell can be alive, and I will color it white, just like this. Then this cell can be alive as well, this cell can be alive as well, and this cell can be alive as well, so for example. And then you have some kind of rules. So for every generation, for every cell in your grid, you calculate the number of live neighbors. So for example, for this cell, I will have like this one is alive, like this one is alive, Yeah, this is that, and this is that. So what for this cell, I will have like one neighbor alive. Then you repeat this process for every cell, and then, for example, for this cell, we have this one and this one alive. So for this cell, we have like two neighbors alive. And there are different neighborhoods, so you can calculate neighbors in a different way. You can take, for example, all those 8 neighbors around your cell, or you can take just neighbor on top, on the bottom, on the left, and on the right. And you can take even more neighbors, so you can basically play around with basic setups for the system. And then you have rules, where you describe that if the cell has one alive neighbor, it's dead in the next generation. Or if the cell has 0 live neighbors, so for this cell, it doesn't have any live neighbors around, so it's going to be dead in the next generation. And this cell has 2 live neighbors, for example, and it's going to be alive. Even if it's dead now, it can turn alive in the next generation. So you basically come up with these rule sets, and then you run your simulation and see what happens. The most famous cellular automata, I guess, is called Game of Life. Okay, I guess I'm not using the right website. And it was invented by a scientist and mathematician named John Conway, and it was 1970s, if I'm not mistaken, and it's kind of a video game, but it's not a video game in the sense that we know video games. It's a one-player video game, and you all you can do is basically you set up some initial conditions for your grid. So the yellow cells are alive, and then you hit start and see what happens. It has some rules, and those rules control the generations and the outcomes itself. And it appears that with a simple set of rules and a simple grid, you can create complex and rather different results. And you can simulate different things. And this concept cellular automata is used in various science fields, like in physics, for example, to simulate fluids or gases, in biology to simulate forest fires, for example, or simulate patterns on seashells, something like that. It can also be used to simulate spread of diseases. So various stuff. And game design, for example, in Minecraft, those cellular automatas are used to generate some landscapes, but it all used in combination with different algorithms like cellular automata, Perlin noise, and so it all mixed up, and that's how Minecraft landscapes are generated. So yeah, in our case, if we go back to our grid, the diffusion algorithm suggests that every cell has some kind of diffusion value. So those initial cells, for example, those that are alive, or our red boxes, have initial diffusion value like 1. And all other cells in the grid have initial diffusion value like 0. And then with every generation, you kind of calculate the average diffusion value for every cell. So if we have a cell with diffusion value 1, and we have all the neighbors with diffusion value 0, then the total diffusion value is 1 for this cell, but we then divide it by the number of neighbors, so 8. So in the next generation, the diffusion will be 1 divided by 8 for this cell. And it happens for every cell in the grid. And Then you kind of visualize this spread, and you get what you get on your screen. You get some kind of a spreading algorithm that is generated by a simple set of rules, and it can grow almost endlessly. But it depends on initial conditions of the grid size and on some rules that you provided. So in our code, what we have here, we have a set of variables like grid size X, Y, and Z, which are responsible for the width, height, and depth of the grid. We also have two variables responsible for colors, like low color input and high color input. They are used to color our grid. So if we choose like blue, instead of blue for low values of the diffusion, we can choose a different color, for example. Yeah, in next generation, it will recolor. And this algorithm produces some kind of interesting 3D forms and cube-like aggregations. In order to control all this madness, we have to use a thing called array. Array, if a variable is a box with some data inside, an array is like a box of boxes. And every box inside this big one has its number, and it has some data inside. And you can address a specific box in this array by providing its number. And what we do here in lines 14 and 18, we create a new array with an array inside, with an array inside. That way we kind of create a three-dimensional, kind of create a way to control a three-dimensional space. So it's like an array, an array, an array. Some basic setups for scene camera renderer, sun shadows, resize, and so on. Then those lines 75 and 80, we randomly select 5 cells. And randomly select 5 cells. Okay. I guess it selects more than 5. Yeah, maybe it's then yeah, it's then recalculated. Okay. So initially it was supposed to select 5 cells that would be of red color here, and we set up for a diffusion value for them, which is 1. Then we kind of create cubes. We have a special function to create a cube. And in this function, we have a geometry that creates a cube. And here we provide not 1, a value not 1, but 0.99, just so that we could see this space between the cubes. It's not necessary. I just thought it would be better with the control net later on, but the workflow will be. I don't think that it will matter for control net. Anyways, just a way to simply make boxes a bit smaller. Then we have a way to kind of come up with a color for each separate box. So we have a low color value, a high color value, and we kind of calculate a color value for a certain box, interpolating, and it is based on the diffusion value of a certain cell in our 3-dimensional grid. We then set up a material and use our color value that we have just calculated, and we create a cube, set up shadows for the cube. We move a cube to a certain position in a grid, and that's it. We then add them to the scene. So what we also do here is we want to kind of make this grid more rows, and that's why we remove every cube, every third cube, every cube that has coordinates that when they're divided on 3 are not the remainder of the division on 3 is not equals to 0. So basically just some mathematic approach to remove some cubes from your grid. You can play around with the numbers here. And we also visualize only cubes that have the diffusion value larger than 0.7. These are some variables that get values from those inputs. We have a function update grid size in order to recreate new grid when we change those values, and update grid button here. And here we have like 10 boxes specified already. So when I click update grid, so initially when the page loads, it has 5 boxes. And then when I hit update grid, it gets 10 boxes. But again, if the coordinates of the box are when they're divided by 3 and the result is not equal to 0, they're not visible here. So you may sometimes see less than 10 boxes, even though the 10 number is written here. Every time we hit next generation, we have to remove previous boxes from scene. That's why we have this line here, like scene remove cubes. And then we kind of recreate the grid again. We remove everything, we recalculated the diffusion values, and we create new cubes with the new diffusion values and new positions. This thing, update grid button on click equals update grid size. It's the same as we did before when we were adding event listener with functions and so on, but written in a different form. Then we have this function next generation that calculates the diffusion value for every cell, just as I described before using the sketch. It creates a kind of a new grid with new values, and well, it basically calculates all the values for every cell in the grid. And then we have condition that if the diffusion value for our cell is larger than 0.002, then we display this cube on our screen. And this value is pretty low because if we get it higher, chances are we will not see any cubes on our screen, just because the diffusion value calculated for every cell is much lower than this value here. Yep. So I suggest you can change those this 3 number here, and you can also play around with this value here. But the larger it gets, the lower the chances that you will see anything on your screen. All right, and then we have like 2 special functions to save screenshot. Saving screenshot works like this. You re-render your 3GS scene again. You use a special command to data URL, which creates an image data in the URL format. And you then create a link element. This link gets this image data. It downloads a file with this specific name that it's written here, and then you kind of simulate a click on this newly created link that you don't even see on the screen. and the download process triggers, and then you can find your file in the downloads folder. And export OBJ. I think to export our 3D geometry in an OBJ format, we need to import an OBJ exporter, a special part of 3GS library. And what this thing does is it goes through your scene, creates a text description of this scene, and then again creates kind of an object of this text description and packs it into an OBJ file. And then kind of simulates the click on the created link the same as was with the screenshot. And you have an OBJ file. And if you want to export a GLB file, it will be a different exporter. But the process, I guess, should be somewhat like this, but I wouldn't be sure. I would check on the docs. But anyway, OBJ works with Rhino and most of 3D software, so that's fine. And the last part is here, orbit control setups and our animate function as well. So yeah, I guess this is it on my side. If you are using this version, you have an option create an image here, and you have something on your screen generated. And if you click create image, it will take a screenshot of the canvas that you have created, and this image will appear here in the text in the chat panel. And the chat panel will also switch to image mode. And here you can provide a description, like what is this on the image. You can say like this is a modern library building in Helsinki, for example. Helsinki, some kind of street view, soft lighting, else, something like that. I guess Alec will cover prompts more than me. And click generate image. What it does, it takes the input image, takes your text description, and uses the control net with Stable Diffusion Excel to come up with something like this. It's not always that well controlled. And sometimes you have to play around with prompts, with the colors, maybe, yeah. So maybe if I grab something like this, create an image with this view, using the same prompt, let's check what will happen. Yeah, it will produce a bit more the different result, but still maybe it's not that controlled. So maybe the colors, maybe you need a different input for a control net, something like that. But the idea is that you can grab whatever you generated here and with a simple quick few buttons generate a more detailed AI enhanced visualization of this thing. And Alec will cover more on how to control this process using ComfyUI. In our plans for this thing specific is to come up with different models, different lures, so that you could use different styles. And of course, you can just grab an image and turn it to video if you want to, or try to turn it into 3D image, a 3D model as well. 3D works well with simple objects like cups or toys or something like that. It doesn't work great with architecture. But I guess as the field develops more and more year after year, we get more in the future. Okay, thank you everyone. If you have questions, feel free to reach out. Alec?
Yeah, I'm here. I think we can make a small pause.
Yep, perfect.
Yeah. So let's do it for maybe 10 minutes. So I don't know how many time you need, and then continue. Yeah. Okay, let's do 10 minutes. It's fine. And on my timer, it's right now 6:43, so 53, or whatever hour you have right now. So we will meet again. Okay, so I think our short break is ending. I will share my screen. Okay, guys, I hope you are returned already. So we still have 27 participants. So it's nice. Usually after Stepan's parts, nobody's alive, but it's fine. So this is a joke, by the way. Okay, let's start with these files actually, and to be sure everything is fine and your setup will work. And after we will produce the workflow itself. The main thing we need to put to several folders, it's the models. It's all these files with the safe tensor extension. And I suppose nothing else. So this is just the reference images. This is for Rhino. I will show you later. Okay, yeah. So what you need, if you already download all this stuff, you need to put them to the several folders, and I will show you where these folders located. And I suppose most of you already know that all this stuff, and maybe you even have these models. It depends on depends on your experience with ComfyUI, and I already have seen that most of you used it previously, so it's fine. But for them who first time open the ComfyUI, so I can show you the idea behind these models and where you need to download them. You have a folder when you install ComfyUI. So in my case, I install this desktop version, this one. Then double click on it, and you will have this ComfyUI interface. Actually, this one, it's my Kodiia. I probably need to close it. So this is the interface, but probably without this workflow or basic workflow by default there. I don't really remember what happened here on the canvas when you open ComfyUI for the first time. But anyway, you have the folder where the ComfyUI installed. So in my case, it's located on disk C. Then I put it to stable diffusion folder because I have like an old folder which I installed a couple of years ago for Automatic 11.11, and it's still here, also Kodiia and some different stuff. And I put to the same folder the ComfyUI. And I also have the portable version, which is installed in the pretty difficult way. If you've seen my instruction before, it's probably provided when you subscribed on this workshop, but it's already outdated because they launched this desktop version, and you don't need to really install this portable version. Anyway, both of them, portable or desktop version, have the same structure of the folders, and we need the models folder to put there all our own models or models which we downloaded from internet, doesn't matter. So all of them located here. And for ComfyUI and for different processes we have a lot of different models. So the base stuff which we need right now, it's LoRa's, this folder, and also checkpoints. So checkpoints and LoRa's. To LoRa's folder, you need to put almost everything you downloaded from my Google Drive, except so these two, for example, the constructivism, this is the LoRa models. You need to put it to the LoRa's folder. Geometric minimalism as well. This and Nunu. So these 5 files, this one, these two, and the constructivism, they all are LoRa models. What else we have here? We have as the Excel Realistic Vision V4, this is the checkpoint model, and you need to put it to the checkpoints folder. And the rest, it's the ControlNet models. The rest is 2 of them, I suppose. Let's check again. Sorry. So it's actually this one, TT Planet, and this one, Diffusers Excel Kani. So these 2 are ControlNet models. So put them to the ControlNet folder. And that's it actually. This is the whole setup. You just need to spread these models by folders accordingly, and you will have everything you need. Okay, then go back to our setup, which we already produced with Stepan, and generate something. So something like that, for example, this fine. And what the idea here actually, usually if you have the complex philosophy or complex workflow behind to producing your project, for example, neighborhood or the city or any other big scale project, you have no time to produce the detailed geometry, and your geometry will probably looks like that, with voxels, cubes, maybe something else, and it's definitely not enough to make a detailed render, realistic render, and you can have a great project and great idea behind it and a really complex workflow, but because of the time pressure, you will have just this geometry. And what to do is, in this case, especially if it's a competition or concept design phase, so we need to okay. I see your question about the checkpoints. Just a moment. And so if you have only this geometry or something like that, you can use AI for render, and it's what we will do right now. And for that, we need to export this object file. This is the 3D geometry which we are seeing right now on the screen, and I will do that, and then I will show you what you missed. Just a moment, maybe I put it like other subject. Okay, it's done. And about the checkpoint model, it is realistic vision. This one is the Excel. I can show you like that. This one, realistic vision, it's checkpoint model. This one, ControlNet, and this one, ControlNet, and the rest are LoRa's models, and you need to put them to the LoRa folder. So again, this is to the checkpoint folder, this is to the ControlNet folder, this is as well to the ControlNet folder, and the rest to the LoRa's folder. Basically, all these models, if you will not have this Google Drive or something wrong with downloading from Google Drive, all these models you can find on the CVTI website. So it's this website with a lot of models. This is kind of library for AI artists where you can download and upload your models and download the models from the others, let's say. And I already shown you my collection with the several LoRa models from different artists, and including my own models as well. And also it's just a small piece of the whole library which you can find on the CVTI, but most of the models, of course, not related to the architectural topic. Anyway, some of them are also useful, especially if we speak about the specific style or specific details which you would like to provide for your images. So you can also use the models which are not related to the architectural topic. So this is the really useful website, and I can copy the link for this collection if you want. And one thing about realistic vision model, you can find it here actually. Realistic vision, it's probably this one. Yeah. So this is the model, this is the base model which we will use. Of course, it's not about architectural at all. It's about everything. So you can create parrots or cars or humans, doesn't matter. But on top of it, we will use the LoRa models to, let's say, tune this base model somehow. It's not a base model actually, but by the way, we will let's say, offsetting this model from the initial position to the architectural stuff using the LoRa models. And the base models are something else, actually. It's either Stable Diffusion, one of the version of the Stable Diffusion. The most popular is SDXL. The last version is 3.5. And also we have Flux models and so it's there are a bunch of models which are based, and on top of these base models, users making the checkpoint models, which are universal stuff, and using the checkpoint models but fine-tuned to the specific style, for example, realistic style or anime style or something like that. You can produce just more images with better quality than using just a base model like that, for example, as DXL. And on top of the checkpoint, we can use LoRa. So it's a kind of 3 steps. I can maybe make a simple scheme for you. So we have first step, second, and third. It's here it's a base models, then checkpoint, which are fine-tuned base models, and then LoRa. So this is actually checkpoint models is the same stuff if we speak about workflow as a base model. So when we are using something like that in the ComfyUI, we either can pick the base model or checkpoint model, and it's not possible to use them, let's say, together. It's kind of possible, but it's not make sense, I would say. And so you can pick either base model or checkpoint models. Usually it's checkpoint models because they are better for producing the quality images. And then with checkpoint model, you can use LoRa. It is simultaneously we need to use them, this and this. And LoRa just a bit change the checkpoint model in the direction we need. In our case, in the direction of the architectural stuff, and moreover, in the specific architectural stuff, for example, deconstructivism style or voxel city style or something like that. So this is the whole idea. And for this exact model, realistic vision, you can see here it's a version V5 already. But in my case, on the Google Drive, you will find this version, V4, which is somehow for this exact workflow better. I don't know why. Maybe it's just about taste or something like that, but I like it more. It's not so contrast in the end, and without some details, which I don't like as well. So this is more realistic model and more detailed model, but the images here are very contrasts on this exact workflow, but you can use this as well. So you can download this model and instead of version 4 use this one or even something else. So it's also possible you can find any other model on CVTI and use it. How to use them I will show you later. And in general, when you download one or another model from CVTI, you can see here the base model, which is really important for us because the whole workflow will be around this base model. For example, if the base model is Flux and you would like to recreate the similar approach for Flux, it will be totally different bunch of nodes in your workflow. So you need to use another algorithm for that to produce the similar stuff around the Flux. The same for actually other models like Stable Diffusion 1.5 or Stable Diffusion 3.5. So if you use the specific base model and the LoRa's and checkpoints models, which are on top of this base model, you need to create the specific workflow for them. So basically, I would say right now, it's 4 base models, still we actually still can use them because other stuff are either outdated or useless or something like that. So these 4 models, it's Stable Diffusion 1.5, which is really old, but this model fast. And even if you have a weak computer or laptop or something like that, you can use workflow with ComfyUI and Stable Diffusion 1.5. So the whole idea. 1.5 is really fast model and it's not require a lot of resources. Then SDXL. It's a really balanced model. In the same time, it's fast and it's allow you to produce the really good images. So it's I would say it's my favorite model right now if we speak about base models. And this is the most popular, I would say. And couple of new models which are launched just this year, this summer. It's Flux and last version of Stable Diffusion. So these 2 models are really nice, especially Flux. Flux has more parameters. It's let's say creating images in a more fancy way and really realistic images with a lot of details. But this model is pretty slow, and this model still has no proper control net, proper let's say IC Light workflow, and a lot of different stuff which you can find for SDXL or for Stable Diffusion 1.5. So because of these new models are still not under development, they are already done, but the stuff which you need to produce on top of it, like control net, IP adapter, IC Light, etc., which are usually produced by users, still not there. And some stuff you already can try, but for example, couple of weeks ago, ComfyUI launched to support these Flux tools, including ControlNet, but it's not a real ControlNet, unfortunately, and you can't use it in the same way as you can use the ControlNet for the SDXL, for example. So that's why today we will focus on the SDXL, and this model, checkpoint model, perfectly fine for us because it's based on SDXL. Okay, and so even for SDXL, you have a couple of versions. For example, SDXL Lighting and SDXL 1.0. I will not go deep into it. Probably we will today use SDXL 1.0, but if we speak about lighting, it's almost the same as the SDXL model, but it's even faster. But of course, the quality of the image is not so detailed like for the simple as the Excel model. And usually such models is necessary to use for real-time rendering if your system, server, or computer able to do that, because it's producing the images just for 4 steps or even faster. So we will not go into such models right now. The workflow for them almost the same, just parameters are different. But we will use the simple as the Excel model and this realistic vision. Okay, I hope you Flux model link. It's not so easy actually because it's not just one Flux model exists. You have Flux Pro, Flux Dev, and Flux Schnell models, and also a couple of fine-tuned models to making Flux faster. So it's a lot of different Flux models, and you can just Google that actually, because all of them except Flux Pro is possible to download. Some of them on CVTI as well, and but basically developers, it's a Black Forest. This is the company who developed the Flux model. They have Hugging Face, and on the Hugging Face page you can download these models. So this is the huge topic actually, which exact model to use. And when we start to making the workflow itself, I will go back to it again. Today we will use this realistic vision checkpoint, which is fine-tuned as the Excel 1.0. So one of them, because it's a lot of different checkpoints which are on top of as the Excel 1.0. Okay, so we have geometry like that. It's actually already fine to have such a graphic to produce an image, and you can try just to make a screenshot. It's also enough for most cases, but I can show you, let's say, advanced approach for that. In my case, I will use Rhino, but you can use any 3D software. And if you don't have something like that on your computer right now, you can just download the screenshots from my Google Drive. I already prepared them. It's black and white images with voxels. You can find them easily, and just download them. It's enough for ComfyUI, but I will show you how these images are done. So first you need to put your object file. I will find it. It's probably here. Just a moment. Yeah. To Rhino. You can just drag and drop it and open the file. This is your option. The only important thing here is this checkbox, map object Y to Rhino Z, because object files they have a different coordinate system where Y is kind of vertical axis, and to put it in the proper way to the Rhino, you need to use this checkbox. So then, okay. And we will have this geometry here. I maximize the viewport. And also I have the special, how it's called, actually, I forget, just a moment. Display mode, yeah, display mode. I have a special display mode for ControlNet and for ComfyUI, because I use this approach really often, and it's called Arctic ControlNet. I tune it by myself, and I already share it with you. You can find this file on the Google Drive. Can I show you? So is this file, arcticcontrolnet.ini. You can download it, and to put it in Rhino, you need to go to the options here, then go to the view display modes and import it. So when you import it, you will see this Arctic control net here, for example. Press OK, and then you will be able to pick this display mode from the list. And you will see this graphic. So can I check the question? As the Excel diffusers should go. I'm not sure I've shared such file, but can I check? Excel diffusers. This one. This one to ControlNet folder. Models ControlNet. Okay. So we have such a graphic, which is good for us. And the last thing we need to do is make a screenshot. So usually better to pick a camera. For example, I like this one. And I also like to point perspective view. Can I change it? It's a set view option. Again, in the perspective, this small arrow to have all these options here. Then you will go set view and 2-point perspective to make your vertical lines always vertical, like that, for example. So, and pick a camera, maybe this is good. And the last thing we need to do is capture to file our screenshot. Like that, 2000 by 2000, it's fine. And press, also, no, we don't need transparent background, the black is good. So press OK. If your background not black, check these display options, and this is the background color, but it should be if you assign this display mode. And so, okay, materials. You can save it in any folder. It doesn't matter where you save the screenshot. I can just check it. It should be here. Yeah, it looks like that in the end. So you can use my previous screenshot, is the similar one. It doesn't matter which one we will use in our workflow. I will just paste both of them later. And these two should be in the Google Drive. This not, because I just save it, but doesn't matter. It's all of them are the same for our workflow. About the Rhino file itself, yes, I can, but it's not really something interesting, I suppose. I will save it, and later you will, but maybe I can even do it right now, just in case. Give me a minute. You don't really need this stuff, but anyway, so it's not here. It's models, yeah. And this is our folder. So I put it to the same folder, and you will have it here. But you don't need it. Actually, it's pretty simple stuff. I just drag and drop it. And for the graphic, you anyway need this ini file, which is already there, because it should be applied to view. And if you don't have this ini file, it will not, the scene will not represent it like that. Okay. Yeah, if you like the view, for example, you can even save your camera. I have this named view tab. If you don't have such a tab, so all of these tabs are somewhere. I forget where is it in the new interface, but yeah, here. Show toolbars. Nope, it's actually not the toolbars, because I tune it once and then I forget where all the stuff located. Probably panels. Yes, panels. So you need to go to this menu. This is the small button, then show panels, and then use these checkboxes to show one or another panels, and this called named views. This one. And you can save the view, the camera, like for example 01, okay, and then you can rotate as you want, and if you double click on this camera you go back to this view, and you can save as many cameras as you want. Okay, this is the small Rhino part, but let's go back into our ComfyUI. So if you launch it for the first time, you probably have empty canvas or something like a basic workflow inside. If you have, I don't know, some nodes here connected to each other, just delete them. We don't need them. To delete these nodes, you can select them one by one, of course. To select several, you need to press Shift key button, and Shift key button is like a plus selection, or you can hold Control button and use the frame to select multiple nodes simultaneously, and then delete. And you will have the empty canvas afterwards, like that. And we will produce our workflow from scratch, I suppose. The only thing which is important to us to have all the nodes which I'm using in this workflow, and some of them are third-party nodes, so it's not by default in ComfyUI. And to be sure everything is here, check this workflow. It's also in the same Google Drive. It's these two files, any of them actually fine for you. Just take this file and drag and drop it to the canvas, or this file, doesn't matter which one. So drag and drop it to the canvas, and you will probably see the message like, I don't know, can I check, for example, with this? So like this, missing node types, and then you will see the list of nodes which are missing. So this is fine if you have this. So what I suggested to just close this message, and you will see the several nodes which are red. So I suggest you to do the same with my workflow, which is here. So just drag and drop this file or this file. You can use either image of the workflow or the JSON file, drag and drop, and you will see this message about missing nodes. Close this message and go to the manager. You will see this manager button here. And here you will find install missing custom nodes button. This one. So in my case, it's not working because probably these nodes which I'm missing, they are only possible to install manually. But in your case, it will be a different result. You will see all these missing nodes listed and install buttons. Install them one by one. So install the first, then install the second, third, etc., etc., etc. And when you finish, you will have the restart button either here or if you close here, and restart your ComfyUI, and you will have all nodes you need for this workflow. The file I dragged, it has more nodes, and the one your screen is less nodes. Is that Yeah, this is fine because I've shown you this one is different file. I just would like to show you how the message look like, but in general, it will be like that. So this we don't need. It's workflow for video, which is the new workflow, and I didn't check it yet. It's a sample workflow from ComfyUI, and I just knew before that it has some nodes which I don't have. And through this workflow, I show you how the message itself looks like, but we don't need this exact workflow. So we only need our own. So it is possible to use the web version of ComfyUI, of course. Yeah, it's fine. You can use any version. If you cannot see the manager, you probably, so I suppose the manager itself should be in this installer, which is for desktop. But if you have the version of ComfyUI which is different, for example, this portable version or the version which is working through any website, for these you need to install the manager separately. This unfortunately kind of problem, but I can show you quickly some stuff. Just a moment. Probably not the up. Just a moment. So you probably should have this instruction because I shared it before the workshop. I can share it again. This for portable, oh, not for, yeah, for portable version of ComfyUI. And this is instruction how to install it. And here you can find how to install for this exact version the manager. I don't remember where is it actually, but I can check just a moment. Yeah, it's here, 2.1 ComfyUI manager. And this is the link where you can find it and the whole procedure how to install it. It's not a huge paragraph, but anyway, this one you need to follow. Find the link how to install the manager, and then you will find the button inside of your ComfyUI. Yeah, with the desktop version, you already have it. You don't need to install this stuff. You should have the manager already inside. Okay. So the manager, it's a really useful thing, and previously it was a separate part from ComfyUI, but now I suppose it's a native part of ComfyUI, and through this manager you can install custom nodes, you can install some models as well, and test some different stuff, update your ComfyUI. So it's a lot of things here which are really useful. Some options also here. So in the end, when you install everything and restart ComfyUI, you will see something like that without red nodes in the workflow. And the only thing here is understand how it works. So, and for that, we will create the new canvas. To create a new canvas, you go to the workflow and press the new button. So there you will have the empty canvas without everything, and we will start with it. While some people installing different stuff, I will make an overview about the interface of ComfyUI. These small buttons with your with it's about health of your computer, but you will probably not see them because it's part of the plugin. And for that, you need to install some custom nodes as well, but it doesn't matter. So it's not a big deal. It's just about your environment, your computer, how healthy it is, which temperature on the graphic card right now, how many percentages you use for the RAM or for GPU or for some VRAM. So it's just to check, but it's not affected your workflow itself. The most important for us is these tabs. It's your different workflows, and you can simultaneously open bunch of them. And for example, if you need to copy the node from one workflow to another, so it's possible. You can just select them, Control C, then go to your workflow, Control V, and you can see this node, which was copying previously. So it's really useful. And you can even switch between them, launch one, then while it's working, check something with another workflow. So it's really useful to have these tabs. Couple of main menus, so it's pretty obvious what all these options are doing. So create a new file, open, save, export. It's I suppose understandable. So also here, clear workflow, it's delete everything from the canvas. So it's other stuff, it's just redo, undo, and help. So this is different websites where you can see the information about ComfyUI and also provide the feedback. Also, we have this side menu. You can hide them through this button. Show menu and hide menu. And on the sidebar, you have several options. So the most important, probably node library. You can see here the all nodes which you can use in ComfyUI, divided by different folders. Most of them right now, in my case, are from the plugins. So it's custom nodes, which are here because I'm installed it through the manager or through the manual installation, which is also possible sometimes. And this, for some nodes, the only way how you can install them. But for most of the nodes, you can use the manager. What else we have here? We have a queue. Queue, it's about your previous works, and you can launch the queue to check what happened previously. And here I can show you difference actually. This is the workflow for SDXL. It's 50 seconds, but this 50 seconds, it's about it's for the whole workflow. It's not just for generating image, but also for upscaling it. So it's just 50 seconds. And if we speak about similar workflow, but even without upscale for the Flux, it's 157 seconds, which is 3 times more, but it's even not a 3 times. It's actually about 10 times because you also need to upscale. And the result, don't pay attention on it. It's because of the workflow itself. It's kind of rough, and I didn't check it precisely. I just test the time. But anyway, so you can see the history which you've done in this session, and you can relaunch the workflow, and you can manage workflows already launched right now. Let's say when we will do that, I will show you how it looks like here. So what else we have? We have models library. Models is different stuff. We already a bit familiar with it. So we just downloaded a couple of models for LoRa's, for checkpoint, for ControlNet. But as you can see, it's a lot of different stuff. For example, VAE models, for example, style models, embeddings, diffusers, etc., etc. So you don't need all of them for the for one or another workflow. For example, for this exact workflow, which we will use today, we only will have VAE, LoRa's, checkpoints, ControlNet, and upscale. So these 5 types of the models which we will need today. But all the other stuff, for example, for the specific cases, for example, these 3 type of models for animation, especially, not especially, but specifically, if you use animated diff model, you need these 3 IP adapter, for example, for workflows with IP adapter, language models, etc., etc. So it's a lot of different stuff here, and this is your library with the folders, and you can see everything here. Workflows is the library with your workflows, and you can add the library from your disk. Here I didn't do that, that's why it's just a workflows which accidentally were saved or basic stuff, so I don't know actually what this file and the last one, it's nodes map. So when you will create something here, let's say just random nodes, you will see this map here, and you can manage your workflow through this map, and sometimes you probably zoom in, zoom out, or focus on these specific nodes through this map. So this is the side menu. We don't need these nodes. And the most important for us is this button is Q, it's launch our workflow, and when everything is ready, we will use this button to see the result. And basically that's it. So also you can switch between dark mode and light mode through this button, and some options. Here is the second button here, and it's a lot of options actually. You probably can for example, change link render mode to straight. It's about this noodle stuff, how it looks like. I prefer straight, and for me this is the, let's say, better way to represent the canvas and workflow itself. Okay, I see the question. In the portable version, in advanced control net node is shown missing and doesn't fix it in the manager where I can get. Okay. If not itself is missing, so and it's not appearing here, which is actually a bit weird for me. Can I check? Custom nodes manager, advanced. Oh, it's definitely part of the ComfyUI. So it's here, ComfyUI Advanced Control Net. You can even find it through the search, and you should install this stuff. So it's not necessary to install it manually, for example. It should be here. I don't know why it's not visible. It should be in the portable version as well, because I used a portable version for this workflow before, and it should be there. But what the issue exactly? It's still red or something else missing? So, okay, interesting. I can't say right now. I need to see what the problem inside there, which exact error, and then search this error, because it's sometimes not the easy stuff. Let's try to recreate workflow, and when we come to this node, we can replace it with something else, because it's not the only way how to use the control net, and I will show you some different possibilities for apply control net without this exact node. queue, it's a launch in your workflow. So when you making the workflow, for example, when you're working in Grasshopper, if we try to compare it with something else, when you're working with Grasshopper, it's always automatically launched. When you add a new node, it's just launched automatically and you don't need to do something. So this workflow in ComfyUI is always freezing. It's do nothing. When you add new node, connect it to each other or do something else, you need to launch it manually, and this is the button for that. So you for launching your workflow. So it's pretty simple. Okay, let's start to produce something, and we will start with our inputs. And we have a couple of inputs, and the first one is our prompt, which is text prompt, and let's start with it. To describe prompt, actually we have like basic notes for that, but I prefer different way. And to do that, I will add the specific node, which is called string literal. If I'm not wrong, yeah, this one, string literal. But any string node actually is fine. If you don't have this, for example, plugin, you can use something else to put your string, and you need something which is string, which has string output and the window to put your text. It's a lot of different nodes and different packages for ComfyUI do this stuff. So to search the node, you need double click on the canvas and then put the node name here. So in my case, it's enough to text string, and you can see a lot of different nodes. So we need this one, string literal. And I can copy it 3 times, Control-C, Control-V, like that, because my prompt will be kind of complex, and I would like to control each part of this prompt independently. And first one, it will be a subject or object, let's say, and I will call it like that, let's say object, which I would like to render. And in my case, it will be a vertical, vertical voxel city or voxel neighborhood or something else. It's up to you, actually, what you would like to produce, or voxel tower, for example. Then, let's say tower, it's even more correct, I suppose. Then I will describe materials, like architectural materials, for example, concrete, stone, or something like that. And in this case, let's say we start with these, made from, and it will be a rough sandstone. Then it will be glass, and for example, concrete parts. And if I would like to have, for example, more glass in my building or more concrete parts, I can maximize or highlight this word for ComfyUI, for neural network. For that, you need to select it or select part of your prompt like that. And in my case, it will be only the glass. Press Control button and up arrow key like that. And this will be the weight to highlight in this part of the prompt. It means it is more important which others, because others already have by default number 1 here. It's just not visible. It's weight equal 1 for these all words here. But for this, we will have 10% more. Let's say it's we need more glass, or it's, for example, if glass not appear in the final render, I would like to highlight it more and use this syntax to assign this weight to this part of the prompt. So again, to do that, press Control button, hold it, and simultaneously press up arrow key button. So a couple of times to make this 1.1. And so this is the materials, and the last part will be location. And location will be, in my case, located in the mountains. And here as well, I would like to maybe like that, highlight it a bit. I usually use the color scheme for different nodes, and for all the nodes I'm using as inputs, I'm use brown color. So I will select them, hold Control button and frame them, then right click on any of them and change the color. It will be the input nodes, so I will use the brown color for them. This is the it's not necessarily to follow me for this color scheme, but I prefer to use such a color code to easily recognize where one or another part of my workflow, and I use several colors. I will explain you later others, but for inputs I use the brown color. And to combine all these three parts, we need another one node, which calls string function. This one. So it can combine three different text, A, B, and C. But in this case, you can just put this part, and this part, and then it's combined all of them three in one text. But we need this three instead of this three. So how we can do that? In ComfyUI, usually for all nodes, you can convert widgets to inputs. And for that, you need right click on the node and find the option convert widget to input, and then convert text A to input, convert text B to input, and the same for the C. So, and then we can connect all this stuff here. So the option is append, it's fine. And this will be action node. And for them, I'm using the blue color. Action, it means it do something. So it's combined, for example, three different text. And to show the result, I will use a show text node. So it's not here. You can actually use this stuff as well. Drag and drop from your output this wire. Then you can search the specific node. In my case, it's show text is already here actually, and it will connect it automatically. And this will be output node. For outputs, I use the black color. So this is the whole thing. And if I queue it, so this is the text which I will have. Let's combine everything with one whole text. So it's how it works. Additionally, we can use some like basic words like award-winning photography or just a good quality photo or something like that. And it's, again, not necessarily, but it depends on the model which you are using. If you go, for example, on the CBTI website again, it's here. Yeah, you can check how this image, for example, were done and which words used here in the prompt. And for example, this common word extremely detailed, or film grain, or dark shot. So it's words about atmospheric stuff. It's not about the object itself. And you can use the same actually. And sometimes even in the model description part here, the developers of the model suggest some words which are good for this exact model. And always check this description. Sometimes they suggest something which is really useful for one or another model. And it will not work with for example, something else. It will be only for this specific model, these words or other words, or specific sampler or specific number of steps, etc., etc. So it depends on what how this model was produced. So, and in my case, I will copy this string node again and add also some common words, let's say 3D, voxels, because it's important for this stuff, and award-winning architectural photo. And also I add the specifics for camera. It will be front view, because sometimes this workflow produced for me like a aerial view or top view, which I try to avoid usually in this specific case, of course. And I also need to combine this and this. We can use the same node or something else. It's up to you. So exist the similar nodes, which is called prompt concatenate. This one. It's better because it's faster in this case. It's already has these two inputs, and it will be also the blue color. Separator, we need space. In this case, we need to specify it. This one, show text, it's do nothing actually. It's just show you the final text, and we can even connect it here and queue it again to see the whole result, the final prompt, which we will have here. So this called show text. Okay, let's go further. This part which is not really necessary to use, but I can show you as well. It's called SDXL prompt styler. This one. You can skip it if you want. But the idea is it's kind of add to your prompt some basic words as well, like this one, for example. But it's already predefined in the library of this custom node. And you can even check this library and add something else inside of the folder of these custom nodes. But I can show you the list of the styles here, which is really huge. And you can see for all, for most cases, not for all, of course, but for most cases, you can find something useful here. And this not just add some specific words like this in the end of your prompt or in the beginning, it depends on. And I will just use the basic enhance style like that, and also convert widgets to input. For example, positive and negative as well. And we so far have a positive prompt. We can check afterwards what will happen here. And we also need a negative prompt for SDXL workflows it's necessary. For Flux, for example, not always. And I will use something simple. We don't need ugly image and deformed object there. So that's it. And put it to the negative. So to see the positive prompt, we can queue it and check what it adds to us. It's also adds award-winning, professional, highly detailed, and also breathtaking in the beginning of our prompt. Okay, let's do it like that. As I already mentioned, it's not necessary to use this stuff, but sometimes it's helpful. And this is our prompt part. If you want, you can group this stuff. I'm not often use groups, but if you select all these nodes, you can add them to the group. Oh, sorry, I forgot how to do that, but you can add the group as itself, and then just move it like that, for example, and then it will be the group. So it's probably possible to do it automatically, but I'm not using the groups so often. So if you like them, you can do it like that. But I try to organize my script through the wires in the pretty obvious way, and groups usually not necessary in this case. So next, our next part is models. So we need to add our models from which we will render everything. And the most basic node for that is load checkpoint, this one. So it's also will be the brown node. And this node, it does pretty simple thing. It's check your checkpoint folder on the computer inside of the ComfyUI model folder and see all the models which are there. And in our case, I will use as the Excel Realistic Vision model. Actually, you can pay attention on the names which I using for the models. I'm usually add this prefix because if you download the models from the CVTI or from Hugging Face or from GitHub, doesn't matter from which source, you will probably see only the name and sometimes as the Excel or Flux mentioned there, sometimes not. And afterwards, it will be not so obvious from which base model this or other checkpoint were produced. And it's pretty important because the whole workflow should be follow the same base model. If you use the, for example, checkpoint model, which based on SDXL, you also need to use LoRa model, which also only on SDXL, and you can't combine, for example, Flux, LoRa, and SDXL checkpoint is not possible. The same for the control net. You can't combine Flux, control net, and SDXL checkpoint or LoRa. So all your models should be from the same category, let's say. That's why I always add this prefix to recognize them easily. And I recommend to do that. And also for organization, this list is also better because they are not mixed. So this is the way how you can do that as well. But some cons as well here, because if you download workflow from CVTI, in this node will be, for example, the model with the initial name, not your renamed model, and you always need to pick from the list your actual name, otherwise it will not work. So it's up to you actually, follow this or not. I will pick this as the Excel Realistic Vision. Oh no, this is the in-paint model. I need this one. And that's it, actually. This node has 3 outputs. Its model itself, it's a clip model and VIE model. So all this stuff baked inside of the checkpoint. Usually, if we speak about SDXL, for example, if we speak about Flux, it's a bit differently because for Flux, VIE and clip are separated from the checkpoint model usually as well. Here is also possible to separate them and use another one clip which is not inside of this model, or another one VIE, but it's not necessary in this case. Basically, this model for render itself, this model for interpretation of your prompt, because all this AI stuff actually don't understand the text itself. It needs to be converted to digits, and this clip model it's for that, actually, to convert text to the digits to inside work, let's say, of these AI models, and vice versa as well, from digits to text sometimes. And this clip model is from OpenAI. It's the same company which produced ChatGPT, and usually for all these workflows we are using this exact clip model for this task. And VIE is for converting images from pixel space to latent space. I will show you later what it means, but it's also necessary to convert your images to digits as well. And for that, you need to use a VIE model. Okay. Model we have, then we need to add our LoRa model, because this one is basic. If you will render architectural stuff with this model, you will have pretty simple buildings like I don't know, glass skyscrapers, or maybe something which similar to the Hadid building but in the bad way, and which organic shapes, but not the fancy organic shapes, but pretty obvious one or simple one, I don't know. So it's better to train your own LoRa or use one of the LoRas I already have shown you, so to get better result, I would say. And to load the LoRa models, it's a lot of different nodes for that, but we will use CR LoRa stack, this one. This node allows us to use several LoRas simultaneously. It's basically how many? 3 of them. So, and you can even copy this node like that and use 6 LoRas if you need, or 9 or more, doesn't matter. We just need 2, so even not 3. And for that we will on switch 1 and switch 2 and pick our LoRas from this list. I will use SDXL geometric minimalism. It's my own LoRa. You can download it from Google Drive or from CVTI, up to you. And the second one which we will use, it's the LoRa called SDXL Nunu, this one. Also, I uploaded to my Google Drive, but you can find it on the CVTI as well. Is this one? It's developed by Ismail Salat. This is the author of this model, and this is pretty nice model which are producing like a minimalistic architecture with the natural materials, with the simple shapes like that. And I really like it to combine with something more, I would say, more detailed or more complex if we speak about shape. And usually this combination gives me a nice result. So this LoRa itself producing really simple stuff, but with nice atmosphere. And if you combine it with something else, you will have interesting result. And these two weights, and it's about how your LoRa affect the model itself and the clip model. So it's affected both your prompt and your work for the render. And it's no rules here how to use these weights. Actually, for some LoRa models, actually you can find some rules in the description of this LoRa model. If you download it from CVTI, again, read this description. You can find some specific, let's say, not rules, but some ideas how to apply one way to another, from one result to another. But usually it's just 100%, or for example, you can affect 70%, which means your LoRa will work not on maximum, but shift the model in the let's say slightly, not for the whole stuff. So I would keep 100% for this first one and put 0.5 here. You can play with it actually and see the result and what it will come as an output. So then we need to apply this LoRa model to the initial checkpoint model. And for that, we will use again CR, apply LoRa stack node. This one. It will be the blue color. And we need to take our model and clip and our LoRa stack to apply. So, and in the end, we will have new model and new clip, which are already shifted by LoRa. This is the whole idea. So, this is the model downloading part. You can also group it, but I actually even delete this one. And then we need to load our image. So for that, we need to use load image node, which is already here. You even don't need to type something. Load image. So this one, it will be input node as well. So it's brown. And I will use this image I already saved. For example, this one. Black and white image. But when I make a screenshot, I forget the resolution, but probably it was about 2000 by 2000 pixels. Sometimes it's too much. You will wait maybe a couple of minutes for producing the render from this resolution. And better to resize this stuff to 1024 pixels. And for that, we will use the image resize node. It's not the one node, actually, it's a lot of them. Oops, resize. And I prefer this one, image resize by longer side. And here we have an image, and the longer side will be 1024 pixels, like that. This is the method for resizing. So I usually use this nearest, but most of them are the same if we speak about the result. Okay, these are our basic inputs. So we have our prompt, we have our model, and we have our image to produce something. What we will need to use to actually produce something. This is the basic node for everything. It's called K-sampler. K-sampler is our engine, I would say. And for these most important nodes, I usually use green color. So it will be like that. And what we need to add here? We need to add model, positive and negative prompt, and latent image. Latent image, it's basically the empty image with the size with pixels, which we need to produce. Empty, it should be like empty latent image or with pixels, with actual pixels as well. It depends on which method you are using to render something, image to image or text to image. So in our case, it will be actually empty image. And for that, we need to have this special node to produce it, empty latent image. So this one we can connect. And this is the action node. So it will be, but it's also an input as well. So it's up to you how to color it. In this case, I will color it as a blue one. And I will convert these width and height to the inputs because we need to pick it from this image actually. So convert width and height to do everything automatically. Of course, we can just put 2024 by 2024 because we know this is the square image. But to make everything automatically, better to use the sizes from here. And for that exists node image size. Get image sizes, so it's fine. You can use this one or this one. So it's from Essentials pack. This is from the Easy Use pack. So it doesn't matter actually which one you can prefer. And we have width and height here. So I can color it the blue. And this will give us an opportunity to make everything automatically if we, for example, change an image here. So this input is fine to us. And for these three, we actually need to apply control net first, because what is the control net? Control net is the special model which take the composition from the initial image, for example, this one, and use this composition for producing something new. And we need to use this composition, this position of the voxels to produce something new. And for that, we need control net. So let's apply it. And in my workflow, which I shared with you before, I use the node which calls apply advanced control net node. But as I already know, in some cases it doesn't work, and you can try to use just this one, apply control net, the simple one. Let's try both. Apply advanced. Where is it? Apply advanced control net. This one. I have two of them. Okay. Actually, you know what? Sometimes I remember it happened with me as well, to me as well. Even if you reinstall something, for example, if it's new version of the package, the node in the old workflow still looks like an as a red node. But when you find this exact node, you can it's allow you to find it and add the similar node here, and you just need to reconnect it. So sometimes it's happening. Check if you can you search this node or not? Apply advanced control net. Probably it's possible if it's already installed. Maybe it's just because of the different version of this package on your computer and in my workflow. Okay, the question, how do you stretch a node to show the full checkpoint name? you can just do it like that. Just drag and drop the corner. Should work. Okay. I hope you will have this node because it's a bit better for our purposes, but you can also use this one, which is native, not from the package. And you can also apply your control net through this simple node. It's also possible. But I deleted for a while and we'll use this one. What we need to connect to this node. First, we need to connect our positive and yeah, this is actually not possible. I will show you why. So we need to connect positive and negative prompt, but if you try to do it directly, it's not actually work because you need to apply clip model first to our prompt because here is just a text. And as I already mentioned, we need to convert this text to the digits. For that, we need to apply this clip model. And for that, we need to use the special node, which is called clip code, clip text and code. Yeah, this one. And we have the input for the clip, but we have only widget for the text. So convert it to the input as well. So we need the same node for the positive prompt, color it to the blue and copy it. So again, clip, and here we need a negative. And now it's working. So it will be also the blue one. So actually for copying, you also have some tricks. Here, if you just Control-C, Control-V the node, it will be without wires for input and output. But if you Control-C and Control-Shift-V, it's already with wires which are inputs for this node. Sometimes it's useful. So it's Control-Shift-V. Yeah, if you have only a simple one, I can just check this as well. Apply control net. You definitely have these same inputs here. So you need to do this one, which is obvious. And then the third node also, third input also the same control net. This is the control net model. And as we loaded the checkpoint model, we need to do the same for the control net model. But of course, exists a separate node for that, which calls load control net model or load advanced control net model. It depends on which node you use, the simple control net or advanced control net. You need to use one or another node. So in my case, it's advanced control net model, this one. And here we need to pick our model. In this case, I used SDXL Diffusers XL Kani, this one. And you can connect it to the control net, either here or here. It's also possible to combine the simple control net with advanced control net input and vice versa. The simple control net load node should connect it to this one, so it will work to you. And basically, so this is the input, it will be the brown one. And if you would like to know where you can find this model initially, not from my Google Drive, you can go to this instruction actually. Sorry. Which I already showed to you. this one. And also it was a question about Flux model. It's also, you can go to this instruction actually. It's paragraph 3, additional models here, and a lot of different links here for different models, for example, for Flux, for SDXL, for ControlNet as well. So this is the ControlNet for SDXL, for Stable Diffusion 1.5 and 2.1 for Flux. So you can see all these links here. I forgot about it actually when you asked about the Flux model, but if you're still here, so you can find the links for different models, including the Flux in this document. So just check it. Okay, ControlNet model we already loaded. It's the simple node as this one. It's just check the folder where ControlNet model located and load one or another. So which you can pick through this list. It's only ControlNet models from this folder here. And you can see all of you downloaded in this list. So, and then we need to connect this positive and negative stuff. It's not just a prompt already, it's a shifted prompt. First shifted through LoRa, because LoRa applied to clip model, and then shifted to ControlNet. And it's not just text anyway anymore. It's already, from here, it's already digits. And ControlNet also shift them to follow this information which coming from the composition, but we didn't apply it yet because we didn't put something here to the image. And this is our next task. So image we also have here is the same stuff. VIE, it's not necessarily to add something to this input. It's only think if you would like to use another one VIE to convert this image from, for example, VIE you are using initially from the model. So sometimes you can provide the specific VIE, but I never seen a case for that. So maybe it's necessary for some video stuff or for some really specific options. But in this case, when we just use one image through the whole workflow, so it's necessary to use the different VIE, just leave it empty, this input. And we only need to pay attention on the image. And of course, you can use it like that actually, because this is already a prepared image for ControlNet. And the Kani ControlNet, which we are using here, the Kani, this is the special type of the ControlNet. There are a lot of types of the ControlNet. Some of them use depth map, some of them use segmentation map, some of them use outlines of the objects like Kani, for example, and outlines like that. It's making black and white map from any image. If you even put a photo here, the Kani ControlNet needs image like that. And you can first convert your initial image to image like that, and then put it to this apply ControlNet node. And for that exists several algorithms. For example, node, which is called Kani H, like that, or this one also will work for you. So these nodes are preprocessors, and these nodes needs to convert your initial image to something else, to depth map, to this black and white map, to segmentation map, and sometimes even something more fancy like a normal map or something like that. It depends on which exact ControlNet you use. Each exact ControlNet has a separate preprocessor algorithm, and for preprocessor you need to either prepare your image by yourself, which we did, or use these nodes to do this work inside of the ComfyUI. So I can actually show you how it works. You need to connect image here and then to your control net. So it's kind of intermediate part. Also, we need to color it to the blue and use the same resolution as we have here. And additionally, maybe better, you know what, to control it automatically, maybe better to make it as an input as well. So convert this size and this size resolution as an input, and then we need like an integer. For example, this node is fine, but you can type integer if you don't have this exact node in the search. So when you are doing this, for example, I have this integer literal, but if you don't have it, you have something else, just type integer and you will find, for example, this one or maybe something else. So this is okay. This is the input. And we need to add the same number to here. So now it's automatically, if I change it here, it will be changed simultaneously in both nodes. And these two parameters, it's about how your image will be converted with how much details to this black and white image. We already have black and white, so I suppose it will be the same in the end, but to see the result, I can use preview image node here. Will be the black one. So as I already mentioned, it's not necessarily to use in this exact case on this preprocessor because we already have the proper image, but to be sure everything is fine, you can even use it as well. If you have like a regular image, like a photo or render or screenshot from the software, which is not black and white, you definitely need to use it to produce in the end the similar stuff. So this node will produce the similar stuff here and send it here. So this is the stuff which we need. Okay, and additionally, which we can use with this advanced control net node, but we can't use it here, it's scaled soft weights. It's a special node which is called scaled soft weights, this one. And we can connect it here. So in general, if you don't have this one and this one, just use strength. It's also working. And the strength of the control net is really useful stuff. It's allow you to kind of keep the composition in the different way, like totally keep it or partially keep it, like only let's say follow the idea of the composition, but not follow the actual position of the lines or something like that. So for that, you can use the strength of the control net. But I find out that there's this base multiplier works a bit better for this exact purpose. So that's why I use apply advanced control net instead of this one. So because for me, this multiplier works better than this one. And you can even combine them sometimes. But in general, you will have more or less the same result with or without this parameter. So just put your positive and negative inputs here and you will have the same situation. I will delete it for now. So let's make our control net a bit softer, 0.9, or if you just have the simple control net, change the strength to, let's say, 0.9 or 0.8 even. So let's see how it will work. And I will also prefer to start not with the 0%, but with 0.1. So what it means actually, start and end percentage. If we imagine our work, where my paint, so if we imagine our work of the render as a line where this is the start of the work and this is the end of the work, and here we have nothing, and here we have the final image and it's rendering. It's the same way as for rendering V-Ray, for example, when you initially have a noise, then noisy images, and in the end we have the clean image without noise. So this is the process. And the control net, as I already mentioned, affect this process to change the positive and negative inputs, change the digits in this matrix to shift it towards the composition we already have. But we can start to apply this shifting not from the beginning, but from any point of the job, and stop this also not in the end, but in any point of the job. And for that you have these two parameters. And to give more freedom to the whole workflow, you can start not from the beginning. For example, of course, if you need to keep the composition precisely, you need to start from 0%. From the beginning of the job. But in our case, we just try to find the idea of the project, let's say. That's why I, for first 10%, give the freedom to this workflow, and then apply our composition for the rest of the job. So this is the whole idea for what these two parameters. And we will start from the 10%, and initially, this case sampler will try to render something not random, because LoRa and model anyway already applied, and this prompt will be applied anyway. So it's already will start to do voxel tower with all these environment materials we already provided, but without keeping this composition. And only after 10% of this job, when it's already done something, we apply this composition, and it affects something, and we will see how it will be. So this is the idea. And we also need to connect our model from here, because we already need to apply LoRa to here. So this will be an input. So this is the brown one. And what we need additionally, so these four parameters we have, this stuff we need to understand right now. And basically denoise, we don't need to pay attention in this case, because denoise is about image-to-image workflow, when you have here not an empty image, and here we have an empty image, so empty latent image. It means it's just a container with the width and height of the image with random noise, which we are applying here without any information. So it's only information here, it's width and height. But we can apply the actual image here. And for image-to-image workflow, sometimes it's also helping us to keep the colors or composition or something like that. And the denoise parameter, it's how you deconstruct this image. And if it's 1, so it's completely deconstruct. If it's like an empty image in the end. If it's less than 1, it's you can deconstruct it by 50%, for example, to produce something new. And if it's 0, it means it will the same image in the end as you have here in input. So we don't need to use this parameter for this workflow, because we don't have an actual image here. We only have empty image. Others we need to use. So first, this is the seed, and the second parameter, and it's how the seed will be changed after we launch the workflow. For example, we would like to launch it several times, and first time it will be launched with seed 0, but second time it will be randomized to something else. So I actually would like to make it as an input as well. So convert this widget to input, and it's called seed, this one, the first one. And of course, it's convert the both parameters because they're both related to seed. And we need, for example, seed everywhere or seed generator or something else. It's a lot of APS seed or even integer. Literal, it's fine to define the seed. So let's say this one, seed everywhere. All of these nodes are more or less the same. So I usually use increment, and let's start with something. Increment, it means it will change by 1. So next seed will be 778. And I always will knew what seed was previously for the previous job without any additional manipulation. Okay, and seed is just a random number, more or less. It's affect your work, but if you would like to check other parameters, we don't know how it affects. It's a lot of formulas behind of this job, and this number implemented these formulas and somehow affected to initial numbers to go to the positive, negative inputs. And to be sure we always have the same number in these formulas, we can define this seed as a fixed one to check other parameters. For example, I would like to check how my image will change if I change this parameter, for example, strength, or this parameter, CFG, or something else. And if I keep the same seed, I will have this. If I have the random seed, I will not sure it's seed affected the different image or not, or this parameter. So this is why this is good for research, for experiments, and for different stuff. And you can use it. If you fixed the seed and don't change any parameter, you will have, if you queue twice, you will have totally same images. So this is the whole idea. What else? CFG. CFG, this is the parameter which, and steps. Steps, it's how long your work will be. Let's start with steps, actually. And for different models, you need to apply different steps. For ISDXL, it's actually fine to have about 20 steps, 20, 25, 30. More steps will produce to you more detailed images, but you can, for example, if you put 100 here, it doesn't mean your image will be better than if you have 25 here. But if you put 1 here and 25, for 25 it's definitely will be better because 1 is not enough to make and render, but 25 it's already enough, and 100 is not necessarily to have so much steps to produce in the render, and you just will have additional job which will make something some details which you don't need, some artifacts, for example, or something else. That's why you need to follow recommendations from the model page from CBTI. When you download, for example, this realistic vision model, you can check recommendations in the description, or if descriptions not there for some models, developers not describe them, you can check renders, and renders on CBTI always they always have this parameter, and you can check how many steps in example files developers used, and use the same amount of steps, let's say. Usually it depends on the model, how it was trained, which base model used because, for example, for lighting models, you need just 4 steps or 8 steps. For the Excel base model, you need about 20-25. So you don't need exact this node, actually. You can use something else, easy seed, or if you don't have this one. So it's come from CG use everywhere. This is the package. But it's not necessary to use this exact node. You can use something else. You probably have it. Also, this node is fine for seed because this is the integer and seed is integer as well. So you can provide your seed through this integer node. It's pretty simple, but what I did and what you can did, just drag this wire, search, and put seed word here, and you can find some nodes you already have. So I have at least 4: seed everywhere, seed generator, seed selector, seed RJ3, easy seed as well, CR seed. I even have, and these 2 as well. So I have about 10 of them, and you probably have 1 of them as well. So just use this method always. When you need something, drag this wire, search, and put the idea what you need. So in my case, it's seed. And you can find a lot of nodes. Okay, connected again. So this is about steps. It's actually this line with the job, how many steps we will have there. And CFG, this is the parameter, which is also you need to check the recommendations from the model page. But in general, this is the parameter. It's about how precise the model will follow your prompt, your text, your words inside of this prompt. And for example, if it's 1, model will not follow it at all, almost at all. If it's about, let's say, 20, model will try to follow it really precise, and sometimes it's bad as well. So usually you need something in the middle, and it depends on the model, what exact borders for this, let's say, totally follow your prompt and not follow at all. These borders kind of not fixed for the whole AI stuff. For each model is different, but for as the Excel type models, you usually need to pick something in between 7 and 10 here, and then you can check with the same seed how it affects your results. Sometimes, for example, 7 is better, sometimes 8 is better, so try to experiment with that. The same for the samplers. Actually, samplers is the algorithm which doing the job itself. It's denoising your initial latent image to actual, not to actual image, but to the image from which it's possible to produce actual image, and a lot of algorithms for that. And these the samplers which inside of ComfyUI and which ComfyUI supports. So you can pick one or another and check how it affects your results. Usually you can use all of them, except, for example, some samplers could not work with the specific models, but for is the Excel, I suppose all of them you can use. And you can check the recommendation also from the model side. For example, for this realistic vision model, they recommend to use, if I'm not wrong, this one, DPM-PP2M. So, and scheduler Karas. It's also from recommendation. The scheduler, it's how the sampler will apply it to the job line, let's say. It's also hard to explain actually, and we will not follow it. But if you imagine the job like a line, the sampler can be more intensive in the start of the work and the less intensive in the end, or vice versa, or it can always be with the same strength. So this is about scheduler, and scheduler it's algorithm which applies sampler to your job. So literally schedule it to your job. So this is the whole idea. And this is the all parameters we need. Then we have in the end latent image with still kind of digits. We need to produce pixel image from that. And we for that we need to use this model VIE and the special not to apply it. It's called VIE decode. Double click to find it. VIE decode. In code it's let's say operation that when we need from image make digits. It's like an opposite operation, and here we need decode. So this is our samples, and this is our model. So I probably rewrote it to be more accurate, like that. It also will be the blue one. And here will be our image. Actually, we can use the preview image node again. We can there are some of nodes to show you images in the end, and most of the people use this one, save image. But it's already, it's not just show you image, it's also save it to ComfyUI output folder. And I usually don't need all the images I produce. So that's why I prefer to just preview it. And if I need it, I can save it from this node as well manually. So it's up to you. If you always would like to save them, use save image node instead of this preview image. But in my case, it will be like that. And I suppose we can already try to launch it and see what this workflow will produce to us. For that, you need to use Q button. So let's check. First, you need to wait when model will load it. You see this green frame around the node. It means this node is working right now. And basically, it's just load the model to the algorithm. Then ControlNet, it's very fast. It's producing the black and white image from the initial image. And then this node start working. So this is the line of the job. You can see it. Then this decoded, and you can see the result. So this is our result here. And if I don't like it, for example, I can queue it again. It's automatically changed because I have the increment algorithm here for the seed. See the another result. So let's check again. You can find your best image, I would say. And of course, you can try to change this prompt to change the materials, to change something else. For example, what if I change it to something like wooden panels, for example, here, instead of concrete parts? We have these concrete parts, as you can see. So it's more interesting, I would say, but this looks like an installation, not like a tower. Maybe try to change the scale and use the city instead of the tower. Yeah, this is better. Let's say this is better. So you can try again, and from actually these compositions, it's even better because it's more vertical, and you can check it. It's probably more interesting. And I would say the glass, I have too much glass here. Maybe I don't need this weight. Let's try again. Yeah, now we have less glass and this is better. So let's keep this one. I will fix this seed. It was the previous one fixed. And yeah, the question how to save it. Save it is pretty simple. It's right click on the image, then save image and save the image wherever you want. But the workflow itself, I already shared with you. So if you need the same workflow, it's already on Google Drive. You can just download it from there. And so it's the same. And then we will try to upscale it because the quality of this image is not enough. It's just 1 megapixel. So let's try to do it more interesting. And for that, we will use the special node, which called Ultimate is the upscaler. This one. So this also kind of engine node. So I will color it with the green. And what we need to do here, actually, we need the same positive and negative stuff, the same model, the same VIE image. So it's more or less the same inputs as we have previously, but we also need upscaled model. This is the difference. And let's start step by step. So first we need an image which we will upscale. This is the image. We can connect it. Then we need the model. The model is this one, which is from already shifted by Laura. And we can connect it as well. So then we need positive and negative inputs. So for that, actually, I would prefer to use another one, ControlNet. And in this case, it's enough to use the simple apply ControlNet node without advanced stuff. And I usually use this method for upscaling. So we can already connect the positive and negative stuff. And sometimes you can use the ControlNet for upscaling as well to keep the initial composition, but add more details to that. And this is the good approach, actually. And what we need to do, we need to provide the initial conditions. Say these two. I rewrote it. This and this, which we add to the previous ControlNet. Here, the same, we need to add positive and negative. So we also need to provide ControlNet model is the same, not like this one, load ControlNet, but actually here I used advanced, better to use the same. So that's why I will just use load ControlNet model without advanced. And for this task, we need this model, ttplanet as the Excel ControlNet. This is the special model for two tasks, one upscale and another task. You can use this ControlNet for change style of the image. In this case, you need to use it here, of course, but for upscale, you need to use it on this step. And I apply it like that, and this will be the brown node. So this is my model, and I also need an image. So here to this ControlNet, you don't need to use pre-processing. You only need to use the actual image like that. So with colors, with everything, without any pre-processing. This is the special type of the ControlNet. where you just need to use the simple image. VIE again, we don't need to use this model. It's already applied automatically, and only if we need something specific here, we need to apply it. So this is the whole setup for this control net. And I also don't need to be very precise, so change this %, and strength a bit, and this will be enough for us. VIE also, we need to connect this VIE, we already have it here, so it's fine, to our upscale node, and is the same VIE which we put in here, so the same model. I usually use actually additional node to avoid these long wires. It's called anyway everywhere. I can show you just seed everywhere, anything everywhere. For example, this one, 3 or 1, and how it's work. If, for example, you connect VIE here, it's automatically recognize it. And if you have the input with the same name, for example, VIE here, or here, or even here, it's automatically connected without wire. So sometimes this stuff is useful, and I usually use it for clip, for VIE, for model, because these wires go across your workflow usually. But this time I will not use it, so just connect it directly. And the last stuff we need is upscale model. Upscale model loader, this is the node we need, so it's automatically suggested us. This is good. And I will use model which is called 8x NMKD Superscale, this one. If you don't have it, you can download it through the manager, model manager, and try to search it here and then install. So this is the basic model. It should be in this list, and just use this name, 8x NMKD Superscale, but it's enough to just start typing, and it will suggest it to you. Again, it's you need to go to the manager, model manager, and usually upscale models you can download through the manager without searching the website or something like that. But if you would like to know from which website this model, you can just use this link, for example, for this ultra sharp model. Click it and you will see where is the website. It's link, all these links to GitHub actually. Okay, these are upscale model, and this is the multiplier, how much we need to upscale. For example, here we have this image in the resolution 1 megapixel, 124 by 124, and if we would like to upscale it 2 times, it will be 248 by 248. So this is the idea. Seed I will fix. It's not necessary to randomize it every time. This is not really important, but sometimes if you, for example, relaunch this stuff, and you will have the same job here, and the random seed here is start to relaunch in the workflow, which we don't need actually, and better to fix this seed. How do you know to connect it to LoRa? You mean what exactly? To connect it to LoRa. Okay, this is not a question anymore. About the computer specification, I have mainly this work with the graphic card. So you need as many graphic memory as you can have, and in my case it's 16 gigabytes. And the graphic card itself, it's NVIDIA 4080, so it's fine for SDXL models. It's not so good for Flux, because for Flux you need even 4090 or 3090, because these cards they have 24 gigabytes RAM, and video memory is really important for all this stuff. If you have more, you have better results. And next year it should be a new generation of NVIDIA cards with 40 gigabytes for desktop cards. And they will even better. So, but for SDXL models, I would say this graphic card 4080, it's more than enough. It's really fast, and you still need to wait, but it's not so long. If you will have 4090, it's even better, of course. So, about the next question. Let's. I will return to a question. Let's launch this stuff, and while it's happening, I will answer your questions. Let's say, and other parameters are similar as you have for K-sampler. So we also need to define, for example, a sampler, and for this job, I prefer to have this one. But you can also check how the sampler and scheduler work, and maybe assign something else. For CFG, I prefer to have 7. We don't need to really follow the prompt itself, because we already have an image and we just need to add some details. And so title, tile width and tile height, this is important stuff. If you rendered like a classical render, it's something with old V-Ray version. I don't remember if the current V-Ray version is still there or not. It's divide the image by small squares and render square by square your image. This is the same stuff, and this is the size of squares which you will have for rendering, and bigger size will be faster, but it has more memory, VRAM memory, graphic memory, video memory. And it means if you have a graphic card with low RAM memory, so you need to decrease this to, let's say, 520 or even 512 or even 256. So check this stuff. If it's working for you for your graphic card, make it bigger. If not, make it less. So other parameters, it's about how these tile stuff will connect it to each other after renders. It's a size of the blur between them, seams, etc., etc. So it's known fix seam mode and different stuff. So if you see the borders between tiles in the end, you can play with these parameters as well. But in general, it's all what you need actually. So, and in the end, we can also sharpen our image a bit. It's just make it more sharp. And so we don't need such a strength stuff. And preview the final image here. Oop. Okay. And I also like compare. Oops. Oh, it's image compare, it's called. This one. Yeah, I believe it's this one, and it's probably go to B, and the initial image which we have here go to A. Oh, this is the whole workflow. Let's try to launch it. It's keep this image because I fixed the seed, and it's only will upscale it. So let's check your comments. Can I show the latent upscale? I actually, yes, I can. I can even provide your workflow where all the upscales for SDXL all together in the same workflow, and you can compare them. But I would say this better than just a simple latent upscale, because this control net provides more details, but I will show you. So let's see. This is the image. It's pretty sharp with the nice details, I would say, and how it looks like. If we use this compare node, you can check your control net is working or not. So it's keep the composition, as you can see. And maybe try to make another one. See it like, I don't know. This one, and let's check. So about latent upscale, I will show you a bit later because it's separate workflow, how it looks like. In the ultimate is the upscale. Can you show again how to add the upscale by and seed? So upscale by and seed, I just put it here. So if you would like to make it as a separate nodes, as I did in my initial workflow here, for example, it's here and here. You need to convert these widgets to inputs, as we did previously for other nodes, and then connect these seed node is, for example, you can copy this one, and for the upscale by you need a float node, which provides simple float number like this one, for example. So, but you can use these widgets as well, so it's the same result in the end. Well, this is interesting, I would say, and let's see how it will upscale. So this is good. You can also check this stuff. And let's check other questions. So it's probably answer to the previous question about latent upscale. In general, I have a lot of different workflows. You can, most of them you can find in my Telegram channel. In the first presentation, I already have shown this channel, and you can just join and download the workflows. I shared before, but for example, for the upscalers, I made this workflow. Here, here you need to put an image. I will share you this one later, and you can already find it with on the Telegram channel. But after this workshop, you will have an email with the materials, and I'll provide this workflow as well for you. So here you need to add an image. You need to pick a model, like a base model, which you will use, and the upscale model. In this case, I use ultra sharp model, but you can also use, for example, this one, which we applied right now for the previous workflow. And it's automatically through this anything everywhere not shared to all this stuff. You can even you can even show it, but I'm not sure it's possible in this version of the ComfyUI, but let's see. Yeah, this one. Yeah, you can show how this stuff connected from these nodes. It's a funny graphic, but so I always forget where is it to hide. Anyway, this model is provided to all these groups. And for example, this is the simple upscale by image, and this is the upscale using model, also the simple one. And this, I believe, the latent upscale. No, this is the with the model as well, but with the node. So it should be here. This also is the control net. This is the most advanced one with the superior sampler and superior model, but it's really slow. So it provides really detailed result, but it's the slowest method. So I not often use it. I prefer this one. So I believe actually upscale image using model. Okay, maybe latent upscale not here, but it's because I don't like it, probably. Anyway, so for latent upscale, you just need latent upscale node, scale latent by this one. And what you need to do actually here, you need to use not this image for upscaling, but this one, samples. And then you need to use the method for upscaling and the multiplier 2 times, 4 times, 8 times, and you will have latent image in the end. And you need to decode it afterwards. So put it here. So you need you can upscale it here, then decode it, and then you will have an image. This is the whole idea. And you can use this method as well, so you can try. Sometimes it should work better. It depends on the situation and different stuff. Okay. Link for Telegram. Yes, I can provide it. Just a moment. This is the link. So do you have any other questions? It's actually a nice image. I can even save it. So if I skip any question, you can also repeat it because the window for the chat is pretty small on my screen. Where do you find the workflows on Telegram? The better way to do that, I can show you just a moment. So if you in my channel here, for example, this is the channel. You can use hashtag ComfyUI. It's usually under the post where you use ComfyUI. The last post about that, it's how to train LoRa models, your own LoRa models for Flux. And for example, here are workflows. You can just download them. And it's a lot of different materials here. If you go, for example, I don't know, back. So you can start with this post, which is usually describe the idea of the next workflow, then just go down, and this is the workflow itself. For example, this is the workflow to convert images like that to images like that, to convert the style. And of course, you need to describe the style in the prompt, and you will have this situation in the end. It should be something else, not origami style, or maybe you can make a breach like in the Baroque style or something like that. I don't know. But this is the initial image which I made with Midjourney, and the image produced by ComfyUI Workflow, which you can download right here. So this is the idea. And you can check other stuff. So it's also, for example, a workflow for AI render, and it's also using ControlNet and a couple of images and IP adapter as well. So you can just download them, and other different stuff. It's this is the channel not only about AI. Sometimes here you can find materials about Beam or Grasshopper. I also sometimes provide Grasshopper scripts. So it's about mainly everything. What I'm interested in the moment, I just put it here. Okay. Looks like we have no questions anymore.
Is that the end, or is there more to show?
Looks like, yeah, this is the end. I already shown everything I would like to show this time, because if we start something else, it will be for a while, I suppose.
Yeah.
So probably this is the end. So thank you for attention.
Thank you, Alec and Stefan. This was really awesome. Really interesting workflows, and a lot of stuff new to me also. So it was really cool to see all the stuff that you guys are doing. And seems everyone enjoyed it. Thank you, everyone that sticked around. We
Yeah.
have a lot of thank yous there. Yeah. So
Thank you,
yeah,
guys.
if there's nothing else, we can end it, and I'm sure people are eager to get back into this with the recording. And yeah, super cool stuff.
Yeah, and if you will have questions in future, you can reach us in these social networks. So be always open to share something or answer your questions, or you can share something with us, for example, your results.
Yeah. Yeah. Reach out and yeah, share the results. We all like to see it. So that's cool. Cool. Well, thank you guys. And thank you everyone who attended. And until next time. See you,
Thank
everybody.
you. See ya.